it is there in your 11th class curriculum. Though the topic itself is not very big, there are few results you have to keep in mind, and they're simple as well. But since it is connected with so many things, you can connect with sequences, series, complex numbers, trigonometry. I mean, if you have good knowledge of those topics, you will be able to do better in this particular chapter. So today I start directly with questions, but in between I'll be explaining whichever result I need. All of you know that a quadratic equation is an equation of the type ax square plus bx plus c is equal to 0, where a, b, c are any numbers, may be real, may be complex. It is called quadratic because degree of x that is present in the equation, the highest degree I mean, is 2. That means a should not be equal to 0, because we are considering ax square plus bx plus c equal to 0. So the coefficient of x square is a. If that becomes 0, the equation is no more a quadratic equation, it becomes a linear equation. While going through various questions in this topic, we will not only be restricting ourselves to quadratic equations. We'll also see equations of higher degree, because there are certain results which can be carried over to equations of higher degree. Let us see the first question itself to begin. It says a polynomial equation with rational coefficients in x has root 2 and root 3 as two of its roots. Which one of the following statements is true? So the equation you have has got rational coefficients. That means a and b and c are rational numbers. Now, you know that when you are given an equation like x square minus 5x plus 6 equal to 0. When you are given this equation, you can find out its roots. As you can see, you can factorize it. It is x minus 2 into x minus 3 equal to 0. Each of the factors can be equated to 0. That means either this is 0 or that is 0. So x minus 3 should be 0 or x minus 2 should be 0. You get the values 2 and 3. But suppose you are given that an equation has got two roots, 4 and 7. Just these two roots. How do you write the equation? A possible method is this. Okay. Now look at this question. It says a polynomial equation with rational coefficients has root 2 and root 2 as its roots. Is it sufficient to write that x minus root 2 into x minus root 3 is 0? Is it sufficient? You must. Suppose I multiply them. Suppose we multiply and try to write the equation. What will you get? It will become x square minus root 2x minus root 3x plus root 6. That means x square minus root 2 plus root 3 x plus root 6 equal to 0. But is this the required equation? It is not, because we are asked to find an equation which has rational coefficients. The roots of this particular, the coefficients of this particular equation we have derived are not rational. So where is the flaw? There is a very standard result that if you have a coefficient with rational coefficients, and if p plus root q is a root, then p minus root q should also be a root. Do you know this result? Okay. Then let us see certain results which connect the type of roots an equation has with the coefficients. For example, if I take coefficient with rational equation with rational coefficients, the result is if P and Q are now rational numbers and P plus root Q is a root, then P minus root Q should also be a root. You cannot have an equation which has 2 plus root 3 as a root, but this is not a root. This is not possible. So if an equation has a root 2 plus root 3, it must have a root as 2 minus root 3 also. This is the case of an equation whose coefficients are all rational numbers. A, B, C you are discussing are rational numbers. That's what was given. A polynomial equation with rational coefficients in X has root 2 and root 3 as two of its roots. Now, according to this result, if root 2 is a root, minus root 2 should also be a root. So what I'm saying is, root 2 is a root. So minus root 2 is also a root. Similarly, root 3 is a root. So minus root 3 is also a root. That means if your equation is to have rational roots, then it must have at least 4 roots, given that root 2 and root 3 are the roots. अगर root 2 root है तो minus root 2 भी root होना चाहिए. अगर root 3 square root of 3 एक root है तो minus of square root 3 भी एक root होना चाहिए. तो कम से कम 4 root उसके होने चाहिए. और अगर किसी इक्वेशन के 4 रूट्स हैं तो उसकी डिग्री कम से कम 4 होनी चाहिए. We do not know what are other roots because these were 2 of its roots. These were not the only roots, they say. These were 2 of the roots, but these 2 roots give rise to 2 more roots. They tell us that there are 2 more roots, so at least 4 roots we come to know. So this equation must have degree 4 at least. So out of these, the minimum degree of the equation has to be 4. This is the right choice. Let's have a look at the choices. It must be a quadratic equation. It cannot be true. Please, last question, sir. It must be a cubic equation. No, it is not a cubic equation. It must be a biquadratic equation. This is also incorrect because must be biquadratic means it is exactly of degree 4. We do not know if there are more roots. Suppose it has got 1 root also. And if now somebody asks you, what will be the equation? Suppose these are the only roots, then you will write the equation like x minus root 2 into x plus root 2 into x plus root 3 into x minus root 3. These are the minimum thing. There may be more roots. Suppose these are the only, then you can multiply them and write the equation. Suppose these were the only 4 roots, then the equation will become x square minus 2 into x square minus 3 equal to 0. In that case, it will be biquadratic. You can see this board. Is that okay? Now, let us at this juncture talk about polynomials and expressions, and let us see how many roots can an equation have. There is standard result. Mind it, whenever I am talking of equation here, I am talking of polynomial equations. You understand what is a polynomial? A polynomial is an expression like this: x cubed plus 7x square plus 5. This is not a polynomial because it is involving sin x. So when I talk of a polynomial, you should have only powers of x, and that too positive integral powers. So this is a polynomial of degree 3. This is a polynomial of degree 5. when we put a polynomial equal to 0, we get an equation. For that matter, whenever you have an algebraic expression, it may contain sin x, ex, cos x, whatever. Whenever there is an expression, when you equate equal to 0, you get an equation. So when we equate a polynomial equal to 0, it becomes a polynomial equation. But for short, I will be calling it just an equation. Whenever I call equation here, it means a polynomial equation. Suppose there is a value of x which makes the equation 0. For example, here x is equal to 1 makes it 0. If you put x equal to 1, it becomes 0. We say that 1 is a root of this equation. But suppose we were considering just this polynomial, we'll say that x is equal to 1 is a 0 of this polynomial because it makes the expression 0. If I take x cube plus 1, this is a polynomial of degree 3, and you can see that x is equal to minus 1 is one of the zeros of this. So every polynomial of degree n has n zeros, exactly n zeros. They may be real, they may be imaginary. Similarly, an equation of degree n, an algebraic equation, that means a polynomial equation of degree n will have exactly n zeros. This is not true about other equations. For example, sin x equal to 0. Let us take this. Sin of x equal to 0. How many solutions does it have? And what do you mean by solution? But how many solutions? 1. X is 0. Sin x is 0. X equal to pi. Sin x is 0. And pi, she says. And pi means at 0 it is 0. At pi it is 0, 2 pi, 3 pi. Even if you take minus 2 pi, minus 3 pi, this is 0. So this is an equation which is having infinite solutions. And what we mean by solution geometrically, suppose I draw x-axis and y-axis, and this is the graph of sin x, and I am interested in knowing what are the solutions of this. So these are the points where the curve intersects x-axis. Okay. If y is equal to x square is there, and you want to see how many real roots does it have, so we would like to see when you draw the graph at how many points will it intersect the x-axis. X-axis has y equal to 0. So 0 is equal to x square. That means x is equal to 0 is one of the roots. So geometrically, when you are drawing the graph of a straight line, when y is given in of any curve, when y is given in terms of x, wherever the curve meets x-axis, you get a root. Okay. So let's go back to the question. What was that? We had to find the minimum degree. So, but we are sure that it cannot be second degree, because if a equation has 4 roots, it has to be minimum 4th degree. Okay. Let's see the next question. This is just a similar problem. What is the degree of equation of the smallest degree with real coefficients, which has 2 plus iota and 1 plus root 2 as its root? Now you can see, since we are talking of an equation with real coefficients, so there is an important result which concerns the equations which are polynomial equations and have real coefficients. It says whenever it has a complex root like 2 plus iota, it must have its conjugate also as its root. If 2 plus iota is a root, then 2 minus iota must also be a root of this. So कितने root हो गए इसके? 2 plus iota एक root है. The other root should be 2 minus iota. Is that valid? 1 plus root 2 is a root. Can we say that 1 minus root 2 should also be a root? That is true only when the coefficients are rational. So here we are not given rational coefficients. Coefficients are real. You can have an equation which has got irrational coefficients or coefficients which are not real rationals. Then this can happen. For example, what about this? I just form an equation. If somebody asks you, can you form some equation which has x equal to 1 by root 2 as root? So I've done it. I've made an equation. For example, if somebody asks you, write an equation which has 5 as a root. So how will I make the equation? Let me write x minus 5. This is one factor. I may write x also. So this equation will become x square minus 5x equal to 0. It has got two roots at least. It has exactly two roots, 5 and 0. तो अगर मुझे एक ऐसा इक्वेशन बनानी है जिसका एक रूट 1 प्लस रूट 2 हो तो मैं बना सकता हूं. Let me multiply x minus 1 minus root 2 by into x. What is this? X square minus 1 plus root 2x. I have got an equation, but the problem is it has got irrational coefficient. इसमें x का कोफिशिएंट क्या है? 1 प्लस रूट 2. तो इसमें वो कंडीशन नहीं लग रही कि 1 प्लस रूट 2 एक रूट है तो 1 माइनस रूट 2 शुड आल्सो हैव बीन अ रूट. Why it is not applicable? Because the equation I have obtained is not a coefficient with rational coefficient. So now the distinction is clear. If the equation has only rational coefficients, then if p plus root 2 root q is a root, then p minus root q should also be root. If it is a coefficient with real coefficient, if it is a polynomial equation with real coefficients, then if a plus b iota is a root, then a minus b iota is a root. So now, so far as this question is concerned, I can see that I am sure of three roots of this equation. One is 2 plus iota, another is 2 minus iota, and the third one is given to us as 1 plus root 2. We are not sure of any fourth root. It may have, it may not have. So it must be at least a cubic equation. So what is the degree of the equation of the smallest degree we can form? It is third degree equation or a cubic equation. Okay. अगर इसमें रैशनल लिखा होता विद रैशनल कोफिशिएंट्स तो 4 हो जाते, क्योंकि रैशनल भी रियल होते हैं. So that result applies. 1 2 plus iota is a root, so 2 minus iota must be a root because the coefficients are rational. Therefore 1 plus root 2 and 1 minus root 2 both should be the roots. Okay, then can you answer second question? Can a quadratic equation have pi and iota as its roots? First thing you should remember, if you are asked to write an equation whose roots are given to you 5 and 3, it is simple. You write x minus 5 into x minus 3, you will get a quadratic. So why can't we get a quadratic? If pi is a root, I is a root, so the equation will be x minus pi, x minus I. What is this? X square minus pi plus iota x plus iota pi. So we get a quadratic equation. I never asked, can we have a quadratic equation with real coefficients? Real coefficient के साथ ये problem हो जानी थी. Because अगर आप, if you are looking for an equation with real coefficients and iota is a root, then minus iota should also be a root. So at least two roots will be there because of iota. And if it is given to be having rational coefficient, then we should remember that pi is an irrational number. Then we could have to add another factor. So people say that pi and I don't go together, but they do go together. I mean, they can have equations like this. And why pi and I don't go together? I mean, any idea? People say that pi and I, whenever they are there, is just a joke. They are always fighting. And why they're fighting, let us see the next slide. the, the cause of their fight is the pi always complains that you are not real. You talk so many about so many imaginary things. And I always say you are not rational. That means you are not logical. That was just a joke. But pi and I go together. In fact, there's another thing that e pi iota. All of them are, these two are irrational numbers and iota is an imaginary number. But they together form a beautiful number. Do you know that? You know this expression? E raised to power iota theta. What it stands for? It's a shortcut for cos theta plus iota sin theta. So what about e iota pi? Cos pi sin pi. So what is this? Minus 1, because sin pi is 0. Let's see the next slide. This is just another joke that they say that e iota pi, and whenever they are together, they always keep fighting. So I says be rational, and pi says get real, and e says get back into line. I mean, why don't you come to line? Minus 1. So they somebody once said that they always spread negativity, but that was just a joke. So e iota pi, this expression is important. Whenever you are dealing with cos theta plus iota sin theta type of things, then you can have you can write them e raised to power iota theta. That helps you in multiplying. For example, if there is something like e iota theta 1 and e iota theta 2, you can see that forming the product will be very simple. Otherwise, you will have to multiply cos theta plus iota sin theta 1, then multiplied by cos theta 2 plus iota sin theta 2. But simply this works. Let us go to the next problem. The roots of the quadratic equation are real and equal. So whenever you have to test this, given a quadratic equation, ax square plus bx plus c is equal to 0, you can, you know how to find the roots. That is pretty simple, that you have done in your school. If this is the equation ax square plus bx plus c equal to 0, then the roots are given by minus b plus minus b square minus 4ac upon 2a, and this 2a is valid because a is not 0. Moreover, this d is b square minus 4ac is called the discriminant of the quadratic equation, and you know that if this discriminant is positive, the roots are real and distinct. It's negative, the roots are imaginary, I mean with a complex part, and similarly when d is 0, the roots are real and equal. This fact is clearly known to you. So when in a question the choices are like this, you have to find out whether they are real and equal, pure imaginary. That means it has got something to do with the discriminant. So we can find the discriminant of this equation. What is that? B is, so what is a? The coefficient of x square is small a, the coefficient of is minus 3b, and the coefficient of, I mean the constant term is minus 4a. So what is the discriminant? B square minus 4ac. That means 9b square minus 4a into minus 4a. So it is 9b square plus 16a square. What is this going to be? We do not know its exact value. But is it positive? Because a square and now that we have studied complex numbers, we should not jump to conclusions. If a is iota and b is 3 iota, this may not be true. So in the examination, it should be mentioned whether a, b, c are real or not. Assuming that a, b, c are real, this will always be greater than 0. So the last choice will be there, because if d is this quantity a perfect square added to a perfect square. So it has to be a greater than 0. Whenever discriminant is strictly greater than 0, the roots are real and distinct. What is the condition for real and equal? D should be 0. And for rational, when will the roots be rational, by the way? Suppose I write the equation like this, the solutions. This is actually the solution of a given quadratic equation. When will this number be rational number? This is a, first of all, B and A should be rational. If B and A are not rational, you will be in trouble. That means if you are given that A, B, C are rational, but is this sufficient? If I write an equation in which all the three coefficients are rational, can I assume that the roots will come out to be rational? No, we have just seen that there may be roots of the type P plus root 2, root Q and P minus root Q, even if all the coefficients A, B, C are rational. So what is the additional condition we require? This should be a perfect square. Suppose B is a rational number, A is a rational number, and D is also a perfect square. That means square root will go away. So what is the condition therefore for roots of a given quadratic equation to be rational? Should I write? Roots of ax square plus bx plus c equal to 0 are rational if A, B, C all are rational and D is a perfect square. When I say it's a perfect square, it automatically means that D is greater than 0. A perfect square can never be negative. So writing greater than 0 is not required. If D will be a perfect square, when it is taken, when a square root is taken, it will give you a rational number. So rational number plus minus a rational number. Then what you are doing now? Minus B plus minus root D upon A. So this is a rational number, this is a rational number, and this also becomes a rational number. So we can rest assured that the result is going to be a rational number. So you have to come to this level at least, I mean, in order to attempt problems that are asked in the engineering examinations. Let us go a step further, see another problem. Find the value of A for which the roots of the quadratic equation are this. Oh, this is not one problem. These are not the choices. You have to do everything, I mean. For what value of A will the roots be real and distinct, equal, not real, opposite in sign, so many things. So we are also trying to understand this concept through it. But this is, you can immediately see that it has something to be related with the discriminant, because the first thing you have to do while attempting a question is how to attack it. So this, because the choices tell you that you have to find out the discriminant. So let us find out the discriminant of this. The coefficient of x square here is given to be 1. So A is 1, B is 2A minus 1, and C is A plus 5. So let us find out B square minus 4AC, which is the discriminant. So B square is 4 into A minus 1 whole square minus 4 into A is 1 and C is A plus 5. Can we simplify it? It is 4a square plus 4 minus 8a minus 4a minus 20. That means 4a square minus 12a minus 16 is equal to 0. And it is a square minus 3a plus 4 minus 4. Sorry, you don't have to write 0 here. So this is the discriminant. 4 times this. Now we are interested in finding out whether this is positive, negative, because on that will depend the answer to these questions. So in fact, these are 5 problems given in one question. I have not written the choices for each one of them. So when will it be real and distinct? When d is greater than 0. So first thing is real and distinct. I don't think I need it. Have we calculated it correctly? This calculation is okay. So can we factorize it further? It is a minus into a plus 1. A minus 4, a plus 1. Only then you will get a square minus 3a minus 4. So d should be greater than 0. That means 4 into a minus 4 into a plus 1 is greater. Similarly, we have to answer all these questions. But here we enter into inequalities. We enter the inequalities. How good are you at inequalities? Inequalities are always more difficult than equalities. For example, if you are asked to write, let me devote some time to that, because many a problem in IIT and other engineering examinations are based on inequalities. So if you are, let us start from a linear equation. Suppose 3x plus 3 is greater than 5 and somebody asks you what values of x satisfy this. It should be simple. I can write 2x is greater than 5 minus 3 because shifting 3 to, if a is less than b, a plus 5 is less than b plus 5. A minus 5 is less than b minus 5. If you add anything to both sides of an inequality, the inequality remains unchanged. But it is not true about division. So now when I divide, I get x greater than 1 because 2 is positive. If you divide by a negative number, the inequality changes. That means for every number greater than 1, this result holds. You can check. Take x equal to 2. Does it hold? 4 plus 3 greater than 5. Take x equal to 3. 6 plus 3 greater than 5. So we have got the correct result. But what about had you been given this problem? What will you do? Minus 2x is greater than 2, then x is less than minus 1. Because now here, if you divide by minus 2, the inequality changes. If you multiply or divide by a negative number, the inequality changes. Inequality, there was no problem. Whether you add, subtract, divide or multiply, the only restriction was you cannot divide by 0. Here you cannot divide by negative numbers without changing the inequality. Is that true? But what about this? This is not a linear equation, it's quadratic. So you know the technique here also? Have you done some problems? Let us see. Now 4 is positive. I'm not interested in 4 now. I'm not interested in 4 because 4 is a positive number. I divide both sides by 4. My intention is to find the values of a for which this is positive. Now product of two numbers is positive when either when both of them are positive or both of them are negative. So there are two cases, either a minus 4 is greater than 0 and a plus 1 is greater than 0, or both of them are this should be positive and this should be positive, or this should be negative and this should be negative. Either both of them are positive or both of them are negative. So what is this equivalent to? I repeat it, either this says a is greater than 4 and a is greater than minus 1, or a is less than 4 and a is less than minus 1. Mind it, there is or in between these two things, but there is and in between these two. So when will this be true? A greater than 4 and a greater than minus 1. That means when both of them are true. So when a is greater than 4, the other one is automatically satisfied. If a is greater than 4, a is automatically greater than minus 1. But if you take a greater than minus 1, it may not be greater than 4. The idea is simple. You plot on a number line, minus 1, 4. This says a has to be greater than 4. That means any number here will do. And this says a has to be greater than minus 1. So what is the intersection of these? This. So these two taken together give a greater than 4. If it is a greater than inequality, then what happens? If a is greater than m and a is greater than n, so you have to choose which one of the two is bigger, m or n. If m is bigger, the result will hold for a greater than n. Whereas in the case of a less than inequality, if a is less than m and a is also less than n and n is smaller, then we should write a less than n. Because what is happening here? A has to be less than 4. It has to be on this side. This is 4. A also has to be less than minus 1. So if some number lies here on the left of minus 1, it automatically satisfies a less than 4 also. So this can be written as a less than minus 1. So that means for the roots of this equation to be real and distinct, we should have either greater than 4 or less than minus 1. Is that clear? Can we find a method of doing it quickly without having to do all this calculation? We'll come to that also, but let us see what has happened here. There was a number minus 1, there was a number 4. They were forming the factors of the quadratic expression whose values we were trying to test. And what was the result? Here and here. Because actually, what was the coefficient of x square here? Had you written a quadratic expression, coefficient of x square is 4. 4 is positive. And you know, if ax square plus bx plus c is equal to y is equal to ax square plus bx plus c has positive coefficient of x square, that means if a is positive, it represents a parabola which opens upwards. You know this fact? Every quadratic expression represents a parabola. Parabolas you know very well. What was the equation of a parabola? Y is equal to x square was one type. So y is equal to x square is something like this. If you have y is equal to x square, you can write it as x square minus y is equal to 0. Or let us not involve y at all. What is the quadratic expression due to which you are getting y is equal to x square? It is just x square. What is the coefficient of this? X square 1, which is positive. So the parabola open upwards. If you have 3x square plus 5x plus 1, it will always open upwards. If you have minus x square 6x plus 9, it will open downwards. This criteria you must keep in mind. Okay. Now, here our expression was something like, let me rub off everything from here. The expression was something like x minus 4 and x plus 1. Instead of a, I am writing x. And suppose you have 4 also here. What is the coefficient of x square? It is 4, it is positive, so it opens upwards. Moreover, it has got two roots, minus 1 and 4. Opening upwards, that means it will come down from here, pass through this root, reach a minimum value and go up. That means on the right of 4, it will be positive. And on the left of minus 1, it will be negative. So without doing the calculations, we could have done it. What was the information we had? If we should have two information. Two things we should know. Number one, what is the coefficient of x square? It is positive or negative, because that will decide it goes like this or like this. Then also what is its discriminant? Because discriminant decides whether it has got a root or not. If discriminant is positive, that means it has got two distinct roots. When it has two distinct roots, it has to be like this if it is opening upward. I'll come to this discussion once again. I'll come to this discussion once again today itself, when we'll be discussing all the things. What happens when d is less than 0 and a is positive? Soon I will cover it. But for this question, it's okay. So now can you try other problems? You do it at home. Equal will be very simple, because you have to put d is equal to 0. So you will get a is equal to 1 and a is equal to minus 4. Actually, that was a will have two values here. Not real means discriminant should be less than 0. Then, okay, now, because what was the expression here? 4a, what was that? A minus? No, a minus 4. This was the expression which we were trying to. This was d. So when will d be less than 0? When this expression is less than 0. Now this expression was positive here and here, so it should be negative in between. For these values, it is going to be negative. So that means from minus 1 to 4, it is going to be negative. I soon come back to this discussion, because this becomes a very important thing. How to see the sign of an expression, algebraic of a quadratic expression, whether it will be positive or negative. So okay, what about the last part? Equal in magnitude but opposite in sign. If an equation has got two roots, they are equal in magnitude, opposite in sign. That means if one root is 3, the other should be minus 3. So their sum should be 0. And do you know how to find the sum of the roots of an equation? It is minus b by a. If we have equation, this I told you in the class when we were discussing complex numbers also. Sum of the roots, which I denoted by, because if this is a quadratic equation, it will have two roots, alpha and beta. So alpha plus beta is given by minus b upon a, and product of the roots is given by plus c by a. First we write the minus sign, then we take the positive sign. So what about this last problem, fifth problem? Equal in magnitude but opposite in sign. That means the coefficient of x should be 0. Alpha plus beta is the coefficient of x divided by the coefficient of a with a negative sign. But suppose I say that alpha plus beta is 0, that means coefficient of x should be 0. What is that? 2 into a minus 1. So here what is b? We want this to be 0. Therefore, we must have the coefficient of x. B is 0. What is b here? 2 into a minus 1 should be 0 and a should be equal to 1. We get the value. Similarly, we can try these things. Let's go to the next slide. Oh, I think we should clearly understand now the relation between the roots and the coefficient once again. Obviously, these questions are not given in your textbook because they do not discuss relation between root and coefficient in detail. But for any competitive examination, these things are must. So for the time being, I will restrict to a second degree equation and we discuss everything about roots and coefficients. If this is the equation ax square plus bx plus c equal to 0 and a is not equal to 0, then alpha plus beta is minus b upon a, we just wrote, and alpha beta is c upon a, and alpha beta are roots of this. Now, this is a problem where they ask you to write another equation whose roots are this and this. Now, you do not have anything here. I mean, the values of alpha beta may not be known to us. So let us take a practical example. Suppose I have x square minus, let us take an example where you can also check, minus 5x plus 6 is equal to 0. Here alpha plus beta will be 5 and alpha into beta will be 6 because minus 5 divided by 1 and again a negative sign taken and 6 divided by 1. Alpha plus beta and alpha beta is known. So now there are two types of problems that can be asked on this. You may be asked to find values of, say, expressions containing alpha and beta. Suppose somebody asks you, what is the value of 1 plus alpha or 1 plus beta, 1 upon beta? This is simple to find. We take LCM, we get beta plus alpha divided by alpha beta, but beta plus alpha is known to us, 5 and this is 6. So it is simple. Suppose you are asked to find out alpha square plus beta square. You know this expression, it is alpha plus beta whole square minus 2 alpha beta, because it is this is okay. What is alpha plus beta whole square? It is 25 minus 12, it is 13. So alpha square plus beta square is equal to 13. What about, suppose somebody asks you what is alpha by beta plus beta by alpha? Let us take alpha square plus beta square divided by alpha beta. What it will be? 13 we have already obtained and alpha beta is given to us. So it is 13 upon 6. So similarly, you may be given any symmetric expression in alpha and beta. What I mean by symmetric expression? This is a symmetric expression in alpha and beta because if you interchange अल्फा एंड बीटा द एक्सप्रेशन डज नॉट चेंज. अगर हम अल्फा की जगह बीटा और बीटा की जगह अल्फा लिख दें, एक्सप्रेशन नहीं बदलता. अल्फा बीटा, दिस इज a symmetric expression. This is also a symmetric expression. If I write beta in place of alpha and alpha in place of beta, it does not change. Whatever expression I have written here, all of them were symmetric expressions. Here you write beta, here you write alpha, it's same. Here you write beta, change beta and alpha, it's same. So given any symmetric expression, you can find out the value. For example, if you are asked to find out the value of alpha 4 plus beta 4, it will be alpha square plus beta square whole square minus 2 alpha square beta square. But now this we have already obtained. What was this? 13 minus 2 times alpha into beta whole square. 13 minus 72. So you get some quantity. But we should not get, pardon, 13 square. That's why I was wondering. It should not be negative because it is 4th power plus 4th power. So 13 square is 169 minus 72. So these checks you can always carry out, because if it's alpha 4 or beta 4, it cannot be negative. So this was given an equation. You had to find out the values of alpha square plus beta square. You can similarly find out, suppose alpha beta square plus beta alpha square. It is simple. Take out alpha beta. But here the problem is a bit different. You have to find an equation whose roots are this. Okay? It's not that you have to find the expressions. Let us see. Shall I rub it off? This. I do 1 or 2 parts of this and leave the remaining to you. Suppose your equation is again x square minus 5x plus 6. I take the same equation, and therefore alpha plus beta becomes 5 and alpha into beta becomes 6. You know the roots are 2 and 3. You want to form an equation. Suppose I take second part whose roots are 1 by alpha and 1 by beta. So if I write, say, P as 1 by alpha and Q as 1 by beta, how you write the equation? X square minus P plus Q x plus P into Q. That's how you write an equation. Any quadratic equation can be written like this: x square minus sum of the roots into x plus product of the roots. Now you are given an equation. Suppose the equation was this one. So now what is P plus Q? P plus Q is 1 by alpha plus 1 by beta. But I know how to find out this. This is 6 upon 5. Let us also find out PQ. PQ is 1 upon alpha into 1 upon beta. That means 1 upon alpha beta. So the value is 1 upon 6. Can I rewrite the equation? X square minus sum of the roots 6 by 5 plus, is this correct? I'm sorry, you did not notice it. Alpha beta, alpha plus beta. It has to be 5 by 6. So it is x square minus 5 by 6 plus 1 by 6 equal to 0. So what is the equation? 6x square minus 5x plus 1 equal to 0. So this equation has been transformed to this equation. So whatever equation is given, you can do this. Equation can be general. Ax square plus bx plus c is equal to 0. Then instead of having alpha plus beta is equal to 5, we will have alpha plus beta equal to minus 5. And alpha into beta is, alpha plus beta as minus b by a and alpha into beta as c by a. Is that correct? So the equation is missing in this because it was general. You pick up any equation and do it. Ax square plus bx plus c is equal to 0. For that you can do this. Similarly, can you form the equation whose roots are alpha plus beta and alpha minus beta? That would be simple. Similarly, alpha square plus 2 plus beta square plus 2, the sum will be alpha square plus beta square plus 4. You already know how to find out alpha square plus beta square. So why did I tell you about symmetric expressions? Because all the results will be similar. This second part can also be written as find, given that alpha beta are roots of a given equation, you will be given the equation, find an equation whose roots are reciprocals of the roots of the given equation. That is similar to this. Or find an equation whose roots are squares of the roots of the equation, part 3. Okay, so they can write it in different ways, but the idea is very clear. From the given equation, we'll get alpha plus beta and alpha into beta, and therefore we can evaluate any symmetric expression in alpha and beta. And when they ask you to find an equation whose roots are so many times the root of this, say thrice the roots of the given equation, then that means you have to take roots as 3 alpha and 3 beta. That means you will write x square minus 3 alpha plus 3 beta into x plus 3 alpha into 3 beta into 1 equal to 0. Equation is, how do you write? X square minus sum of the roots into x plus product of the roots equal to 0. That's how you write the equation. So I think so far as quadratic equations are concerned, now you understand the relationship between the roots of a quadratic equation and the coefficients of the quadratic equation. And these results are true whatever are the coefficients. They may be real, they may be complex, they may be rational, anything. Similarly, whether roots are complex numbers or real numbers, it does not matter. The result is always true. Okay, can we proceed? Okay. So this was actually not a problem, it was a class of problems. Go to the next question. This. It says, for what values of theta does the equation x square minus x minus 1 by 4 cos theta equal to 0 has real roots? Oh. The second part won't be asked. For what values of theta will the roots be rational? This is, I've left it for you. I mean, I will explain you, but it's a bit difficult to find. Find out the discriminant of this, x square minus x minus 1 by 4 cos theta. Because the moment it says, show that it has real roots or imaginary roots or equal roots, you have to find out the discriminant. Here in this equation, it is x square minus x minus 1 by 4 cos theta. This is the equation. So what is A? A is 1, B is minus 1, and C is minus 1 by 4 cos theta. What is discriminant? B square minus 4AC. It is 1 minus 4 into 1 into minus 1 by 4 cos theta. That means 1 plus cos theta. Now, the question was, for what values of theta is this real? That means when is D positive? The question becomes, when is 1 plus cos theta positive? Can 1 plus cos theta be negative? At what value? 1 plus cos theta. Can cos theta exceed 1? Can it go below minus 1? It cannot. So cos theta cannot go below minus 1. And for 1 plus cos theta to become negative, you must have cos theta like minus 2 or minus 3. It will never happen. Cos theta will not have any value less than minus 1. So at the most it can have minus 1 at say pi or similarly. So 1 plus cos theta, that means this result holds for every theta. Discriminant is always greater than or equal to 0. That means it has real roots for all values of theta. Had it been something different, suppose your discriminant comes out to be, this is okay first of all. Suppose you are given a problem and this comes out to be half plus cos theta. Then half plus cos theta can be positive, it can be negative. So you can find out the values in the first quadrant where cos theta becomes more than half, where it is less than half. And similarly elsewhere. You may be, to simplify, you may be asked in the examination to find those values which lie in the first quadrant and for which this is less than 0 or greater than 0. Okay. But if they give for what values of theta, if they ask you for what values of theta will the roots be rational, I just gave you this, I've just written this problem I want you to think over this. But let me give some clues. Now since the discriminant is coming out to be 1 plus cos theta, and what is the condition for it to be rational? D should be perfect square. But before that, A, B should be, A, B, C should be rational numbers. 1 is a rational number, minus 1 is a rational number, but minus 1 upon 4 cos theta we cannot say. So first of all, you can, that means you cannot decide about it, because first condition is when 1 by 4 cos theta is rational. So finding out those values of theta for which cos theta is rational is a bit difficult job. But you know certain values. It has value, cos theta has value 1 at 0 or minus 1 at pi. So when it will become rational, or other values, it has got a value 1 by 2 at 60 degrees, at 30 degree it does not have. So that's why I'm saying it would be difficult. Finding out those values of cosine of theta, those values of theta where cos theta is rational, it would not be a simple job. But suppose we just ignore that condition, although that is important. How to guarantee that this is rational and that also perfect square? Suppose cos theta is negative. So minimum value it will have is minus 1. So this expression will at the most become 0, smallest value. Otherwise it will be something like 1 minus something. Suppose x. Suppose x is suppose theta is equal to say 45 degrees. So that this will become 1 minus 1 by root 2. But that is not a perfect square. So now the question becomes, what should we take x so that 1 minus x becomes perfect square? But we can find such values. Say for example x equal to half, x equal to 3 by 4, x equal to 0 is one choice, x equal to 3 by 4. Because this number is less than 1. So cos theta will definitely take value 3 by 4 at some point. I do not know what is that value. It is approximately cos theta is 0.75. So it should be near 0, because at 0 it is 1. At 30 degrees it is 1 by root 3 by 2. So somewhere in between. So x is 3 by 4 is one choice. And similarly we can find out other choices. Moreover, the expression here was 1 plus cos theta. cos theta can be positive also. So then 1 plus say 36 by 30 11 by 25. If I choose cos theta is 11 by 25, what will happen? 25 plus 11, 36 divided by 25, it will become a perfect square. But such numbers are difficult to find. So that's why I told you that this thing is difficult to be asked in the examination. Then they will specify it very clearly so that just 2 or 3 possible values are there. So there will be some values of cos theta for which 1 plus cos theta will become a perfect square. But at the same time, that has to be matched with that coefficient should be also rational. So this question nobody will give that way. But if you try to find a few values, say find 5 values where everything is okay, that will be a good exercise for you. Okay. Oh, you have read functions also. No? So here in the next problem on this slide, I'm interested in this problem in the same slide, last slide, actually, that y is given to be division of 2 quadratic expressions, and you are interested if x is real, what is the range of the function? Now this is a problem which we are discussing in quadratic equations because it involves quadratic expressions, but basically it is a question of functions. You are very clear about functions? When you write a function as y is equal to fx, then x has to be chosen from certain set, that is called a domain, and it will give some values which are called the range of this. That means a function is something like a machine. From here you put x, here you get y. Suppose I take fx is equal to x square. I can put in any real number. I'll get a positive real number, either positive real number or 0. So if somebody asks you what is the range of this, you will say non-negative real numbers. It can be 0 or it can be positive real number. So here you are being asked, if x is real, what is the range of y? What values can y take if x is real? Oh, let us try to solve it. This involves a little bit of calculation, but it's a good question. So y is equal to x square plus 34x minus 71 divided by x square plus 2x minus 7. We solve it or I just give you an idea? We simplify x square plus 2x minus 7 is equal to x square plus 34x minus 70. We bring everything to this side and collect the coefficients of x square. It is y minus 1. Then let us collect the coefficients of x. This is equal to 2y from here and minus 34 from there, and then the constant term which is minus 7y plus 70. And you can see that this becomes a quadratic equation in x. So what is the coefficient of x square? It is y minus 1. We call it a. What is the coefficient of x? It is 2y minus 34. And what is the coefficient of, the constant term? What is? Please check whether the calculations are okay. So a, b, c. Now since x has to be real, discriminant of this should be greater than or equal to 0. Question is, if we have to input only real values of x, what will be the value of y? And it says if this is true, then this is true. If this is true, then this is true. That means x must satisfy this quadratic equation, and therefore x should have, for x to have real values, discriminant of this should be 0 or greater than 0. So d is b square is 2y minus 34 square minus 4 into a into this. This you can try. This will give you a quadratic equation in y, and quadratic equation, when you are given in y, you can always decide for what values of y it is greater than 0 and for what values it is less than 0. As we did in the last case, either factorize or we will use the method which I am going to discuss in detail. But the idea should be clear. How should you attempt this question? I have kept it here only to give you an idea that problems can be framed like this also. It's okay? Okay, let's proceed further. I'll leave the calculations. Okay, I think this is the high time I should discuss about the sign of a quadratic expression, because this question concerns exclusively with the sign of three quadratic expressions: when it is going to be positive, when it is going to be negative, or less than equal to 0 or greater than equal to 0. With the help of this, you will be able to solve the last question as well, or the previous question where we actually factored and did everything. Okay, this is something very important. I told you that if for this expression, quadratic expression, ax square plus bx plus c equal to 0, plus c, a not equal to 0. If a is greater than 0, what happens is the parabola is something like this. It opens upwards. Okay? It can be anywhere. I mean, even this is possible. Anything. But I'm sure a is positive, then it will open upwards. If a is less than 0, then it opens downwards, something like this. It may be like this, it may be like this, anything like this. It may touch the x-axis, it may cross the x-axis twice, or it may not at all intersect with x-axis. Similarly, the case is there. You can have two intersections, you can have one intersection, you can have no intersection. But now, what is the role of D? Discriminant. If discriminant is positive, you have two distinct roots. That means this is the case of D greater than 0. This is the case of D equal to 0. Let me write a bit bigger. And this is the case of D less than 0. Because when D is less than 0, there is no real root. That means the curve does not intersect the x-axis. So now you can see the combinations. If A is also positive and D is also positive, the curve will intersect upwards. Will open upwards and will intersect at 2 points. When A is greater than 0 and D is equal to 0, the intersection will be just at 1 point. The roots coincide. It will have equal real roots. And if D is less than 0 and A is greater than 0, the situation will be something like this. Right? Now, can somebody tell me, if this function is fx, what can we say about the sign of fx? Given function fx is positive, greater than 0, means whatever x value of x we choose, it is above x-axis. Suppose, let us concentrate on fx, general function. Suppose this is the graph of fx. So when is fx greater than 0? Here fx 0 से बड़ा होने का मतलब है कहां कहां पर बड़ा होगा, जहां जहां पर उसका कर्व एक्स एक्सिस से ऊपर रहे, और कहां पर छोटा होगा जब एक्स एक्सिस से नीचे रहेगा, नेगेटिव होगा वहां पर fx लेस देन 0. इसमें इन दिस यू कैन सी fx is always positive. fx positive means the expression is positive. That means if a is greater than 0 and d is less than 0, then the expression is always positive. Similarly, when a is less than 0 and d is less than 0, this is the case of d less than 0, the expression is always negative, because a is negative, the curve is opening downwards, and d is negative, the curve is not intersecting this, so it cannot go there. Above axis it cannot come, because if it goes above axis it will have to intersect at 2 points. It does not. If it touches x-axis it will have to have one root, which is not true because d is less than 0. So d less than 0, a less than 0 implies the curve is below the x-axis. So here I can say this is a case where f dash x is f of x is always negative. So these expressions have to be seen like this also. Other cases are clear. If a is less than 0 and this is the case of d greater than 0. D greater than 0, why? Because it is intersecting in 2 points. And a is less than 0, so open downwards. So here for some values between this point, these are the roots alpha and beta. So between the roots, it is going to have a positive sign. Otherwise, negative sign. So function fx is greater than 0 when it lies between alpha and beta, and less than 0 when it lies outside the range alpha beta. So these things you have to keep in mind. We can just formulate it also. What happens to this case? This is a simple case. D is equal to 0 means touching here. So the curve will always satisfy this. Fx is less than equal to 0. One thing you should note down. If you leave these two cases when d is greater than 0, what happens in other cases? Have you observed it? So many things are there. 6 things we are checking up. D positive, D negative, D equal to 0. A positive, A negative. So all possible combinations. But you can go home and you'll find it in any books on competitive examinations. But you can recall also at home. Suppose I am talking of D less than 0. In D less than 0, there are only 2 cases, this and this. Either it is always greater than 0 or it is always less than 0. And you can see always greater than 0 means when A is positive. Always less than 0 means A is negative. So that means if D is less than 0 for a given expression, you just see what is the coefficient of x square. If that is positive, the expression will be positive always. If it is negative, the expression will be negative always. So for D less than 0, it's simple. Now I'm trying to extract results from this jugglery, we come out of it. If for a given quadratic expression, discriminant is less than 0, what we have to check? Only the sign of A. If sign of A is positive, the expression will always be positive. If sign is less than 0, that means negative, the expression will always be negative. This is done. Now you see at D is equal to 0. That is, so this done and this done. Let us discuss the case D equal to 0. D is equal to 0. now let me rub it off so that we have clear space. This is clear now, and this is clear. Let us consider two cases when d is equal to 0. This was one case when d is equal to 0. Here also you can see when d is 0, there are only two cases. Either fx is greater than equal to 0 or fx is less than equal to 0. This case is just similar, but at one point the value is also becoming 0. And there also it has connection with the sign of a. When a is positive, fx is greater than equal to 0, and when a is negative, fx is less than equal to 0. So result is just similar to that of. That means in cases when d is greater than 0, listen carefully. When in the case when d is greater than 0 or equal to 0, the sign of the expression goes with the sign of the coefficient of x square. If a is positive, fx is positive. If a is negative, fx is negative. With the only difference there you have to also take fx greater than equal to 0 and fx less than equal to 0. So the only problem is in the case of when d is greater than 0, because there the curve is not entirely above x-axis or entirely below x-axis. So this is the case. Now see, here there is a reversal. When d is greater than 0, certainly you have two roots. One root is alpha, the other root is beta. It can be like this, it can be like this. You can see when a is positive, the function is negative between alpha and beta and positive everywhere else. Outs for more than values more than beta and for values less than alpha. That means outside the interval alpha beta. And when a is negative, it is the expression is positive. When d is greater than 0, you have got two roots. So we get three intervals. One interval from alpha to beta, one from beta up to infinity, one from alpha up to minus infinity. When a is negative, it is negative. When a is negative, it is positive within the roots and negative outside. And when a is negative, it is positive within the root and negative outside. Yes. And if a is greater than 0, then it is negative within the roots and positive outside. I think this point is well taken. You go home, give it a thinking. If you can draw the graph for a greater than 0, less than 0 separately, and for d greater than 0, d less than 0, and d equal to 0 separately, and then combine, that would be the best option, best way to learn it. So now you can do it. What about the first question? 3x square minus 5x plus 6. What is d in this case? 3x square minus 5x plus 6. D is b square minus 4 into 3 into c. This is 25 minus 72. Negative. So sine of x square is 3 positive. So this has to be positive. In the next case, I have taken x square plus 5x plus 6. Discriminant will be greater than 0 because it's 25 minus 6 minus 24 is 1 positive. Now this is greater than 0. And what are the roots of this? This expression is definitely wrong. Because when d is greater than 0, it will have two roots and it can never be always positive or never negative. It crosses x-axis. That is sufficient for this question. But you may be also asked to find out when it is positive and when it is negative. Because the roots are minus 2 and minus 3, you will plot minus 3 on the left, minus 2 on the right, because x square has got positive sign, so it will be negative inside. Something like this will happen. If had x square been negative, it would have been the other way. Similarly, the third you can check up. It is x plus 2 whole square. इसके लिए हमें कुछ करना भी नहीं था. X plus 2 whole square is going to be positive always, except for x equal to minus 2. But if you apply this result, what is discriminant? It will come out to be 0. Perfect square है, come out to be 0. So d equal to 0 वाले केस में what happens? See the coefficient of x square, it is positive. The function is going to be greater than or equal to 0. So this is correct. The first statement is true. The third statement is true, but this is not true. The middle one. This is something very important. On the basis of this, so many questions are asked in engineering competitions, even in IIT. So shall we proceed? So this I wanted you to know. That's why I've included this question. Please go to the next problem. Oh, I have also given the hint here. Can you see it? For what value of a do we have x square plus ax plus 4 always greater than 0? What is the coefficient of x square? 1. It is positive. So you want the expression to be always positive. D should be less than 0. So find out D. D is b square minus 4a square minus 16. This should be less than d square is okay because it is b square minus 4ac. Itna hi. Something else? A square less than 16 means a lies between, because if a becomes more than 4, square will be more than 16, and if a is less than minus 4, again is that okay? So these problems are also interesting. If you know how to do it, it will take just a second. Otherwise, you will get involved into this. Trying to find out, suppose you want to calculate, find x, the values of x, guessing when it will be positive, when it will be negative, will be very difficult. Let's take the next question. Oh, here it is not only one quadratic expression, it's a rational expression in which numerator you have a polynomial expression, in denominator also you have a polynomial expression. I wanted to explain you this result also. Of course, when you are trying for your, appearing in your 11th class questions, examination, you can leave these problems of this type, but they're very important. The idea is just to factorize. Can we quickly factorize one of them? X square plus 4x plus 3. What are the factors? X plus 1 and x plus 3. What is the other? X square, sorry, x cube minus 6x square plus 11x minus 6. Can you factorize it? Factorizing a cubic equation means try to find one root by hit and trial. When you put x is equal to 1, you get 1 minus 6 plus 11, you get 0. So that means x minus 1 is going to be a factor. This theorem is known to you? Yes. Welcome to remainder theorem, and if x is equal to a satisfies a given equation, whatever be the order of the equation, then x minus a is a factor. Now you can write, suppose I divide this by this, because I want to obtain x cube, I write x square, I'm directly writing. And what I'm getting, when these are multiplied, minus x square, so I must have minus 5x, so this will give me minus 5x square, minus x square, 6x square, and plus what? Plus 6. I think whatever way you factorize, you do the long division. I'm not spending time on that now, because I can see we have just seen 1/3 of the questions. Okay, doing more is not important. Whatever we do, we should do thoroughly. X, are these the factors? Are these the factors? Now I tell you a shortcut technique for this. What you do is, when will this become 0, x plus 1? When x is minus 1. So the values of x you are getting are minus 1, minus 3, 1, 2 and 3. Find out all those values for which this is happening. The factors are becoming 0. So it's minus 1, minus 3, 1, 2, 3. Arrange them on a straight line. Where they appear, minus 3, lowest, minus 1, minus 3 is the lowest, then minus 1, then 1, then 2, and then 3. And you can see that draw a curve like this. Starting from taking this as positive and draw the curve. So that means for greater than 3 it will be positive, in this it will be negative, and this will be positive, and so on. Apply this technique. You can check for any one of them. Suppose you choose any value greater than 3, it will come out to be positive. So these are the intervals when it is going to be positive. This. Because you may have a number of try this. After your examination, when you actually start preparing, you have one more year. Then look at, pick up any book which has given some questions from the competitive examination and also has discussed some theory. Then you will see such results there. So basic idea is to factorize and then checking up, because otherwise if you do not know the result, it will be very difficult for you. You do it and check it up. I want to take a few more important things because very less time is left out. I actually want to take some concepts more rather than examples. So will you do it? Everybody should try at home. If it is there. But we'll be losing our time. Okay? Okay. There's only one or two, three. Okay. Give me. Conditions for roots of a quadratic equation not being equal. When it is equal, when d is equal to 0. So the condition is that d is not equal to 0. Discriminator should not equal to 0. Because when d is equal to 0, that root d part will go plus minus. Why are the roots coming different? Minus b plus minus square root of d upon 2a. This d, when it becomes 0, this plus and minus has no meaning. Just you get minus b upon 2a. Next question, let's see. What is the use of making graphs for discriminant? Oh, graphs, I told you that if you have to find out the expression, a sign of a quadratic expression, that it does not depend only on the value of a, it also depends on the value of d. Because value of a, whether it is positive or negative, only determines whether the curve is, your graph is a parabola, upward open parabola or downward open parabola. D is telling you its position with respect to x-axis. If d is less than 0, parabola will be either of this type or of this type, because it is not going to intersect with coordinate axis. This is the case of d less than 0 and a positive. This is the case of d less than 0 and a. Similarly, I have discussed other points, other possibilities, because without d greater than 0 is telling that it is crossing your x-axis. For some values it is positive, for some values it is negative. Anything else? Explain questions 1 and 2. Oh, go back. 1 and 2 must be on the pages 2 and 3 perhaps. Back. Oh, is it that is being asked? Okay. Degree of the equation of smallest degree with real coefficients. Because 2 plus iota is a root, and whenever an equation has got real coefficients, then it must have 2 minus iota also as a root. Complex numbers always occur as conjugate pairs. If 3 plus 5 iota is there, 3 minus 5 iota should be there. So if 2 plus iota is a root, then 2 minus iota should be there. But then the third root is given to be 1 plus root 2. So at least these three roots will be there in the equation. That means it must be at least of degree 3. And second question was, can a quadratic equation? It was just a question of can we form a quadratic equation? Yes, you can always form a quadratic equation 2 roots. And how is that? X square minus sum of the roots plus into x plus product. So there is nothing special about pi and I. You will write pi plus iota x square minus plus pi into iota equal to 0. Given any numbers, you can do it. We go to the next question. Okay, this is a simple question. How to do it? If the roots are real, that means you have to find out the discriminant. Find the discriminant and check. Put it equal to 0. That would be simple. Or should I do it? I think these two choices are discriminant. I hope comes out to be something like 4 of AD plus BC, something like this. You check up, or should I do it? Let me do it. I wanted to do a question on modulus, in fact. I don't know, we have a very little time. You try this, this will be able to do. It's just a big expression. You find b square minus 4ac and see what happens. For them to be equal, it should come out to be 0. Show me the next question. Oh, modulus function, you know, mod of a number is always positive. This function. This is given, then it says what is the value of x? What will you do? Let us put mod x equal to y. The equation becomes y square minus y minus 2 equal to 0. And this can be simplified. Factorization is minus 2 y plus 0. This implies y is equal to 2 and y is equal to minus 1. And what are the choices? Mind it, you have to find the values of x, not the values of y. That is the confusion. Somebody may just write the 2 minus 1 choice if it is given. Luckily, it is not there. Or somebody may just jump into conclusion that none of these is a choice. But these are the values of y. We are interested in values of x. So if y is 2, then mod x is equal to 2. This implies x is plus 2 or x is equal to minus 2. Is there a choice? But it is there in two choices, in B as well as C. So let us see the other options also. This is, I wanted you to note down. This is not possible. Y is equal to minus 1 is there. So mod x cannot be minus 1. So clearly it is 2 minus 2. Let's take another problem. हाँ बताइए. How to find the range in question 6. Oh, I told you that uh, from the given equation we change into a quadratic in x, and when we obtain, because we want x to be real, the discriminant should be greater than 0, and discriminant was an expression in y. Suppose after simplifying you get this. I did not simplify that. Suppose after simplifying you get y square minus 5x 5y plus x. This is not what we will get. So we want this situation. We want that the values of x should be real. That means the discriminant should come out to be greater than or equal to 0. And you noted that discriminant was a quadratic equation in y. When you simplify, you will get something like this. Now we have to find out when is this greater than or equal to 0. Now again, this is an expression. Suppose this is the answer. So what are the factors? That's why I left it there, because it was simple. Now the coefficient is y square is positive. So if you plot where is 2, where is 3, between the roots it is negative, and outside the roots is positive. So less than 2, less than equal to 2, and greater than equal to 3 will be the choice. But I hope you have understood that I have not written the exact expression you will get from there, but you will definitely get a quadratic expression and you will be able to factorize it. Most probably the problems are given in such a way that they are simplified ultimately. Okay, do we have time? Please explain the concept of range. Oh, yes. Suppose we take a function as fx is equal to 2x plus 3, and x is to be given values, say from 0 to 10. Let me take a simpler. Suppose x belongs to this set. That means this is a function. A function is something like this. You can put in 0, you can put in 1, you can put in 2, you can put in 3. What will be the outcome? That is decided by this function, 2x plus 3. What is 2x plus 3 doing? It will multiply 0 by 2 and add 3. 3 will come out. When you put in 1, 5 will come out. When you put in 2, 7 comes out. When you put in 3, 9 comes out. So this is the range now. Range means values of y which you get when you put the values of x, and which values of x you are permitted to put in, which are in the domain. Because I told you it's a machine. In a machine you cannot put everything. Suppose this is a grinder for grinding certain things. So you cannot grind stones in this. You can grind some spices into this. So stone is not permitted. So certain things are not permitted. Similarly, fx is equal to root x. This is a machine which takes the square root of everything. You put in anything, it will take the square root. Suppose you put 16, it will give you 4. You put 9, it will give you 3. 6, it will give you root 6. But can you put minus 1? You cannot put if it is a real valued function. If we want the function to give you real values, you cannot put in minus 1. So minus 1 is prohibited. So x has to be positive here. So the range will be positive real numbers. Square roots. Square root of 1, square root of 2, square root of 3. That means you can, since you can put anything x, any x which is greater than or equal to 0, you will start getting numbers like 1 by 3. When will you get 1 by 3? When you put in 1 by 9. So the range of this will again be positive real numbers. You put in any positive real number, you get a positive real number. So range here will be positive real numbers. Anything else we have? And do we have time? Okay, thank you very much. We could not complete what we intended to, but let's hope sometime we get another class and we go to some advanced problems. I had collected some problems which had already been asked in IIT. I'll see to it if they can be sent to you in your tabs. Those problems you can try. Okay, have a good day.
यहाँ से अपलोड होके इन बच्चों के पास अवेलेबल रहता है? अच्छा, वो बाद में मेल करेंगे आप ना। Yes, yes. Okay, good afternoon, students. Today we are taking the gravitation. Before I start this chapter, I would like to mention one thing, that what we are learning in gravitation, we are going to use the similar concept, not exactly in 12th class in electrostatics also. So this chapter, in fact, is giving you the baseline for electrostatics. Though there is some difference, we'll discuss this in the due course of time. But understand each and every aspect of the gravitation to your depth, so that you can make use of it in future also, right? So we are starting from, initially I'm giving you some of the important points. Let's start from the basic property or the fundamental property of the body, that is mass. I'm sure that you are aware of it, that there are certain basic properties of the body. For example, mass, charge. Why we call them fundamental? Because these properties are inherent, present in the body. We are restricting ourselves to the mass part. When I say mass, it basically gives me the amount of the quantity possessed by the body, due to which it behaves in two different manner. One, it experiences a gravitational force with other body in the surrounding. Secondly, it also possesses the inertia. So in fact, mass is normally is expressed either as the inertial mass or gravitational mass. But what this mass in fact is doing when we talk about the gravitation, how the gravitation or gravitational force comes into the existence when the body is possessing a mass. This of course is a very basic and fundamental question. Modern theory says that there is an exchange phenomena. There's exchange forces basically, and these exchange forces are because of what we call as gravitons. Gravitons are those elementary particles which are exchanged between the bodies, and they are then producing the gravitational force. Here I would like to tell one thing. It is still is not possible to isolate a graviton. Many experiments are going on. People are trying to explore that what these gravitons are. But a word exchange forces I would like to explain a bit in the coming slides. We'll just understand how these exchange forces are working. Take an example. There's a person A. He's having a ball in his hand. A person B also is having a ball in his hand. And they simultaneously throw the ball towards each other. When they throw the ball towards each other, next slide, sir. Obviously, when you throw a ball, what you will notice, you have to apply a force on the ball. What the ball will do? Ball will put a reactionary force on you in the opposite direction. As a result, this man is experiencing the force in this direction, and this man will experience a force in this direction. Next, sir. And when once the balls are exchanged, next, balls are exchanged, if these balls have the same mass, there is no net change in the mass of this man, and same, there is no change in the mass of this man. But the coming ball to his hand is again putting some velocity in this direction, or overall we can say when they exchange these balls, they will experience some kind of the force which may be bringing them apart. Nothing in total has changed, but force has appeared. In fact, this is one example which doesn't fit well to the gravitational force, because gravitational force is always a force of attraction. It is not a force of repulsion. But I'm just giving you an idea that how these exchange forces are working. Anyway, we'll not go in this part that what are gravitons and how these gravitons then they will bring the gravitational force. Will remain to our classical theory given by Isaac Newton, as you know, and we call this as the law of gravitation or Newton's law of gravitation. Next slide, sir. I'm sure that you are familiar with this expression. According to the Newton's law of gravitation, if there are two bodies of mass m1 and m2 and at a finite separation r, the very first thing is that they have a force of attraction. There is no way, we haven't find out any such case where two bodies they are repelling each other due to gravitational force. They always attract each other. Since they attract each other, symbolically we have put a negative sign. It is just to represent that there is a force of attraction. But if I talk about the magnitude of the force, you can drop this negative sign because magnitudes are always positive. So this force depends on two important things. One is the product of the masses m1, m2, and second is the square of the separation between the two, r square. You may say like this, the force is directly proportional to the product of masses and inversely proportional to the square of separation. Here I have listed some of the important properties of this gravitational force which you should keep in mind, and they'll really help you to solve the problems. First thing is that this force is a central force. What's the meaning of the central force? It means that the force of attraction is always along the line joining the two, right? That means there is a specific center there. But as a result, since it is a central force, due to the gravitational force, listen carefully what I'm saying. Due to gravitational force, there is no net torque produced on the other body if you choose the axis passing from that mass. What I'm saying, look at this. If I say that this is M1 is experiencing a force in this direction, and I choose an axis passing through M2, if I take an axis which is perpendicularly passing through M2, since this force of gravitation is acting along this line, there is no torque. There is no torque. And since there is no torque in this system, the total angular momentum of the system remains conserved, provided that you choose an axis passing through M2 or M1, whatever you take. Whenever you have gravitational force, you can make use of the law of conservation of angular momentum, provided that you choose the proper axis. What I mean by this, let's take an example. Sun and Earth, they are having a gravitational force of attraction. If I choose an axis passing through the center of the Sun, or rather the axis which is passing through the center of mass of the two, the total angular momentum of the system will remain conserved. You can make use of it whenever you need one equation. There are many situations where we have to solve for given physical quantities, maybe 2-3 physical quantities, and sometimes we need more equations. So for this, you can make use of it using the central property of the gravitational force. Then there is a term called conservative. This force also is a conservative force. What's the meaning of the conservative force? Nothing, no, not that way conservation, neither be destroyed nor be produced, nothing of this type. The meaning is, if I make this body to move from one position to another position by any of the route, either straight or by a curved path, the work done by gravitational force is going to be same. That means work done in moving a body under the gravitational force from one point to another is path independent. This is a concept, you keep it in mind, right? This is important. This force is always a force of attraction. We don't know even today why it's so. Why not we have a gravitational force of repulsion? I'm not going in on this in detail, right? I'm leaving it. And one more important thing regarding the forces, that this force is independent of the medium present in between the two bodies. If I have these two bodies in free space, that means in vacuum, then even then this force is same. Or I put these two bodies in water, or maybe I'll put any sheet in between, the gravitational force between the two will remain exactly the same. That's why this G, which is nothing but is a constant of proportionality, is sometimes called universal gravitational constant. The word universal comes because whatsoever may happen, if the two bodies, masses are fixed, distances are fixed, in between whatever it may be, the force always remains same. And this G has a fixed value, although it is given to you, but you just try to remember the value, 6.67 10 to the power minus 11. This is very important, minus 11. Minus 11 makes this force the weakest force known in nature. Right? If you compare it with the electrostatic force, there the constant is 9 into 10 to the power 9. And here we have 10 to the power minus 11. It's the weakest force, but there is a very interesting thing, that this force is a long range force. That means if you talk about the two galaxies far away from each other, even then there is a gravitational force between them. Even if it is small, it's there, right? So the range of the gravitational force is up to infinity or even beyond that, right? Next slide, sir. There is another way of handling this concept. While we'll do the questions, and you'll see that sometimes we use the unitary method. Let's take one example. If I say I have a pack of 5 apples, all of the same size, and the cost is 100 rupees. Can you tell me what will be the cost of 7 apples? 5 apples in 100 rupees, 140. How we have reached to this conclusion? Look at this. What you have done in your mind? You have done first of all the calculation for one apple, that is 100 rupees divided by 5, 20 rupees. And then what you did? Multiplied it by 7 and got the answer. So we call this as a unitary method. Is a very basic principle we are using in elementary classes. But anyway, how we are using it here in gravitation? I have a body, say of mass m, and there is a point P. Okay. I can put a body of mass small m, or I can put a body of mass other than small m, maybe m dash, something like this. Obviously, the force is going to be different because force depends on the masses. If I give you an idea, yes, if I'm putting at point P, the force is F. What will be the force if I put a mass m dash there? What you'll do? You'll first of all calculate force divided by mass to get the effect on unit mass. And once you calculate this, then whatever the mass I'm putting at P, you multiply it with that mass and you get the force expression. See what I'm saying? I have a mass small m kept at the point P. This information I'm giving to you, yes, between this mass m and capital M, the force is F. Right? In next situation, I say I remove the mass m from here, and instead I'm putting another mass, say m dash. And you tell me how much is the force? No need to go to the force. What you can do is you always calculate this quantity. That means force per unit mass. Similar to the way we calculated the cost of one apple. If I get cost of one apple, I'm able to get the cost of 7 apples, maybe 10 apples, 15 apples. It's very easy. You keep on multiplying those numbers which are given to you by the cost of a unit. Same, the force experienced by a unit mass, if I multiply this quantity with the mass placed at that point P, I'm able to get the information for the force. This quantity, force per unit mass, is called gravitational field intensity in a proper way, or in short, sometimes we say the gravitational field. In fact, this is gravitational field intensity. But force by mass also is acceleration. So we sometimes represent this by G, sometimes we represent it by E. Symbols may be any, right? But this is in fact is force per unit mass. If you take it in magnitude, then what all you have to do is you have to remove this m from here, and you get this formula Gm by R square. This is the property of the point. This is the property of the point. If I give you this value, that at point P, the gravitational field intensity is so much, right? I'll give you some quantity. Now, you know, if I replace any mass at this point P, you can easily calculate the force, the gravitational force, by simply multiplying this mass with the gravitational field intensity. So it is serving a kind of a help when you talk about the gravitational interaction between the bodies, right? This is the point. Next step. Associated to this, we have a concept that is called the acceleration due to gravity of Earth. You will get number of questions based on this. In fact, this is the same G, that is the gravitational force per unit mass. If I have a unit mass, say for example, this is a unit mass, and if I allow it to fall freely, it is moving down because of the gravitational force of Earth. If it is having a unit mass, then at this particular point, whatever the acceleration it picks up, that is nothing but is the gravitational field intensity. On surface of Earth, if I take the Earth to be a sphere, I'm using a word, if I take Earth to be a perfect sphere, it is not. This is a simplified version. And say of mass m, and its radius says capital R, then on its surface, according to the relation for the gravitational field intensity, the relation is capital G m, the distance between the center to this point, and that is equals to capital R whole square. This must be the acceleration due to gravity. It appears that this quantity is constant because mass is constant, radius is fixed because of a spherical shape. This is the constant quantity, it is not. There are a number of reasons for the variation of the acceleration due to gravity. The one and very important one is the rotation of Earth about its own axis. All you know that Earth rotates from west to east. Are you sure? Is it from west to east or east to west? West to east. How are you sure about it? Because sun appears to be going from east to west, and in sun earth relation you can treat sun to be at rest. Let me tell you, it is not at rest, but for simplicity I can treat the sun to be rest. Then if earth is rotating, sun will appear to be moving in the opposite direction. What will happen if earth is revolving about its own axis? When a body is revolving or rotating, then anything on it will experience a force which comes because of its rotation called centrifugal force. You might have noticed that when you are traveling in a bus and bus take a circular turn, you feel as if you are getting a force in the outward direction. Nobody is pushing you. It is only because you are in a frame which is a non-inertial frame. In a non-inertial frame, you always have a force which we call as a pseudo force, radially outward, and we call this as a centrifugal force. There are many other pseudo forces also. Let's not go more in detail. We are only taking the centrifugal force. Look, if I have a body here on the surface, along with the earth, the body also is revolving, right? And if body is revolving, then definitely there is a centrifugal force in radially outward direction. That means the body, along with the gravitational force, is experiencing one more force, which is trying to bring the body outward, or you can say there is decreasing the gravitational force, and because of which we get a relation. Look at this relation, G dash is equals to G minus R omega square cos square lambda. Try to understand each and every part of it. This small g is basically this one, Gm R square equals to G. It's a fixed value. R is the radius of Earth. How much is the radius of Earth? 6,400 kilometers. It's an average value. It's not perfect value, obviously. From pole to pole, the distance is less as compared to the diameter along the equator. So for simplicity, we'll treat this as spherical body, though it's not, but, and this lambda is nothing but is called latitude. At equator, the latitude is 0, and as we move towards the pole, the latitude increases from 0 to 90, right? Remember this. So this omega is nothing but is the angular velocity of Earth's rotation. Cos square lambda, this lambda factor is because of latitude. From this relation, there are few things which we must remember. The acceleration due to gravity is the least at equator. Why is least? Look, cos square lambda. Cos 0 is 1. So it means this negative factor is having a maximum value. If it is having a maximum value which is subtracted from G, it will reduce G to the maximum. That means G at equator is minimum. But what happens at pole? Lambda is 90. This factor is obviously is not present there. So G is maximum at pole and G is minimum at equator. Okay, you remember this? Then there is a factor which is the factor of the height. How the height affects? There is a relation which tells us that gravitational force is inversely proportional to the separation square. So if I am moving away from the surface of Earth, then definitely my distance from the origin is continuously increasing. Obviously the gravitational force keeps on decreasing. So at this particular position, which I say is at the height equals to h, the gravitational force is F is equals to gm divided by r plus h whole square, because we always take the distance from the center of earth to that particular point. So this is the radius, this is the h, and that makes it r plus h whole square. I do one simplification. What I do is I take r square and divide by r square is not going to fit my equation. But gm by r square, if I take this part, that is nothing but is equals to small g. So I do one thing. I take it this way, that is gm by r square. This f small m also will be there if I put a mass here, m, because force is equals to the gm by r plus h square, that is acceleration and mass. So if I bring this on this side, I call this as g dash, and that is equals to, this makes it small g r square divided by r plus h whole square. So if h is increasing, denominator is increasing, then effective acceleration due to gravity keeps on decreasing. There is one additional formula for height, but with some conditions. Look at this. H is very, very small as compared to r. If I'm talking about, say, I take a body to a height of say 5 meter, 10 meter, 20 meter, 100 meter above the surface of earth, which is very, very small as compared to the radius of earth, I can use this formula, g dash equals to g 1 minus 2h by r. But if the height is not so small, then you are bound to use this formula. This is a general formula and this is a special formula. But for competition questions, you have to be very clever. But how do I come to know that the height asked in this case is very small? Look at the options. 4 options given to you. You go through the option. If you find they are comparable to the radius of earth, you immediately get an idea, yes, we have to go with the general formula. If height is very small, say few tens of meters, 100 of meter, then you can use this formula. There is no hitch in it, right? We'll do few questions based on this, how to solve it. But this is the point where you must put your thoughts before you actually apply a formula, whether I should apply this formula or this formula, right? Then there is another reason for the variation of the g, and that is due to the depth. Can I say earth is a uniform sphere? We can't say. As you move inside the earth, the density of earth keeps on increasing. Increasing rather, change to him. Increasing. Why is it increasing? Increasing because of the gravitational force. The inner portion is experiencing the gravitational force, a kind of a pressure due to the gravitational force, and the density keeps on increasing. But if I assume density to be same throughout, to keep the thing simple, I can use this formula for the depth. G dash is equals to g 1 minus d by r. When you remember all these formulas, it's very important to remember here we have 2 and here we have just d. But depth always is taken again from the surface inward. Can you tell me what is the acceleration due to gravity at the center of the earth? 0. Why so? Because depth is equals to the radius of earth. If I put d equals to r, r by r is 1, 1 minus 1 is 0. So acceleration due to gravity becomes 0. So now one should be very clear about it, that as you move inside, g is decreasing. As you move above the surface of earth, g again is decreasing, right? So is maximum on the surface. But assuming there is certain assumptions we have in these equations that we are treating the earth to be a uniform sphere. What will happen if it is not a uniform sphere. In my last lecture, I told you when you have this type of a situation where the uniformity is not there, we then do one thing. Do you remember the example of the watermelon? I told you that what you should do if you want to eat a watermelon, you have to divide it, you have to slice it. We do the same if there is a variation of density, say from center to the surface, right? We'll take it in that question. But here there are certain assumptions which we must keep in mind, right? Next question. Sometimes we make certain imagination, and these imaginations are of extreme help to us. We have discussed about the gravitational field. Gravitational field in general is the force experienced by a unit mass. That means if this is a body of mass m, if I put a unit mass here, it will experience the force in this direction. If I shift that unit mass here, then what will happen? The force will be in this direction. Again, it's a force of attraction. Being a central force, it's always towards the center. Same is the case here and here and here. If I put in my mind that the direction of the force is represented by a line like this, I call these lines as the lines of force or gravitational field lines. You can't see these lines. These are only imaginary things. They are not reality. These are the imaginary line such that the tangent to it at any point, if I draw a tangent at this point, then that will always point in the direction of the gravitational field, right? You treat a mass from everywhere, these lines are coming and merging at this particular point. We call it as a gravitational field line. It's a concept, right? Next. There's a law. But before I go for this Gauss law, I would like to explain one term which is called the gravitational flux. See, this is blue is a circle or a closed loop, and many gravitational lines are passing through it, right? Can I thought about a quantity which will tell me how many lines are passing through it in total? You can say, sir, you can draw a line in between also. And if you be more accurate, you can draw many lines through it. To make this a physical quantity, we have one term called gravitational flux. And look at this. It is mathematically equals to the surface integral. That means you take entire surface. And that small element we call as ds element, the surface element, if I multiply by the gravitational field intensity at that point, and I integrate it over the surface, whole of the surface, I will count those number of lines. I call this as the gravitational flux. So this is a new quantity for you. Gravitational flux is basically the measure of the number of gravitational field lines, or in mathematical sense, you can say it is a surface integral of gravitational field intensity. Getting my point? This makes very interesting things here. Look, gravitational field is a vector quantity, right? And surface element also is a vector quantity. And if I take a dot product between the two, then what I am getting? A scalar quantity. Look, intelligently what we have done. Instead of dealing with a vector quantity, by taking a gravitational flux, now I have changed it to scalar quantity, which is more convenient to handle, right? I can do with gravitational field intensity, no problem. I can handle the problems of gravitation by using a vector quantity. But if I can do it with scalar quantity, it will be an ease for me, right? We'll exploit this concept in solving the problem in an easier way. Because we call this as a gravitational flux. The law is the main law for which we are doing it, is called Gauss law of gravitation. What this Gauss law says, there are a few things which we should remember. It says that you choose a closed surface. You take a surface which is closed. It's a three-dimensional surface. It's not a loop. It is a three-dimensional closed surface. Take a small element anywhere on the surface, ds element. This surface element is always taken perpendicularly outward. This is a condition. And take the acceleration due to gravity, or you can say the gravitational field intensity at that particular small elemental surface. Take a dot product. But this time you are integrating over the surface, but for a closed surface. Look at this circle. This integration is having a circle here. When you find this circle there, you just immediately put in your mind that we are doing this surface integration for a closed surface. That means this law is applicable only when you take closed surface, right? That is equals to minus negative. Capital G is the universal gravitational constant. 4 pi is a constant. Then the summation of the mass mi in that system which is enclosed by the surface. See what I'm saying? G is the acceleration due to gravity or gravitational field intensity. This ds is a small surface element. Small surface element. Surface element is always taken perpendicularly outward. Take a dot product. Whatever the quantity you are getting, that quantity see, if you take quantity G, which is a vector quantity, and take a surface element ds vector, and then I integrate it over the closed surface, all right, the law says that this is nothing but is equals to G negative sign, a constant 4 pi, then the total mass enclosed by the surface. This helps me in simplifying my problem. I need not to take the masses which are present outside. Suppose some masses are present even outside this surface, I need not to count them. I'll count only those masses which are present inside the surface, right? I'll give example and I'll prove this to you, that how we can make use of it in solving the problem in an easier way. But you remember this law, this is a very useful law. You'll study the similar law, the Gauss law, even in electrostatics in your 12th class. Next slide. See, there is another scalar quantity. I hope by now you understand this. In mechanics, we have two ways of solving the things. One by force concept and other by energy concept. With dynamics, we have two ways in which we can solve the problem. One, use the force, which is a vector quantity, or use the energy concept, which is a scalar quantity. Both these have their advantages, disadvantages also, that we have to check according to the question. But this concept of potential energy, I hope all of you are familiar with the gravitational potential energy. Gravitational potential energy sometimes is written as mgh. You must have used this formula many times. But do you know that this formula has certain restrictions? Can you tell me the restriction in this case? It means you should not move to a point where there's a variation of g, right? That means your height should be as small as possible as compared to the radius of Earth. If you are using this formula, please keep it in mind that h should be very, very small as compared to the radius of Earth. Otherwise, what will happen? G will vary. We have studied this thing. Variation of G is there. Moreover, this is applicable only for the point masses. It means if I have a body which is having almost negligible dimension, only then I can use it. Otherwise, I have to use center of mass concept in this case. Right? We discussed this aspect even in previous lecture. But this is always taken with respect to a reference or reference position in calculating the height from that reference position. But there is a general formula for gravitational potential energy. And what's this? This is given by the relation here. U is negative F dot dr from infinity to the particular position. Please try to understand each and every aspect of it. All you know that the work is a scalar quantity. It is not a vector quantity. This is the work done in bringing a body from a position where there is no gravitational force. If the two bodies are separated by an infinite distance, there is no gravitational force. From zero gravitational force to the position where the separation is R, whatever is the work done, we call that work gets stored in the body in the form of gravitational potential energy. If I solve it for two body system, that means I'm taking a mass m1, m2, and then a separation R. The gravitational potential energy is given as minus G m1 m2 divided by R square nahi. It's only R. Why I'm keeping this negative sign? I told you there's a force of attraction. This is indicative of it. But this gives a very interesting thing. Suppose I take these two bodies now to a separation which is more than R. What happens to the potential energy? If there are two bodies at separation R, I am taking them away to positions where the separation is more. Is that the potential energy is increasing or decreasing? It's increasing because of this negative sign. Why is it increasing? Let's understand it from physics point of view. If the two bodies are here, they are attracting each other, and when you are trying to bring them to a position where R is more, you are doing the work. Where your work is going? Work is increasing the potential energy of the two bodies, right? That's why whenever you use this concept, please do not remove this negative sign. When I write expression for force, look, force is minus G m1 m2 by R square. That was the first relation with which we started. I told you can remove this negative sign from here and can say, okay, this force is the magnitude of the gravitational force of attraction. That is agreeable. But if you remove negative sign from here, it is not agreeable, because this itself is a scalar quantity. You cannot remove the negative sign from a scalar quantity. So whenever gravitational potential energy is used, we always use this negative sign here. You may argue, sir, why we are not using a negative sign here then? This is the formula we are using almost from 6th class onward, potential energy mgh. We are not using the negative sign here. Why you are saying that we should use the negative sign? In fact, this is not the potential energy. This is the difference of the potential energy between the reference position and the position where you kept your particle. If this is the height, I can say my reference position is at lesser distance as compared to the body position. So obviously the potential energy here is more. Whatever is the potential energy at this place, say U1, if I treat this as zero, if I treat this as zero, then the potential energy at this point will be more by a factor mgh. So in this sense, that the increment in the potential energy if I raise the body to height h is mgh is agreeable. But if you try to write exact relation, then you please do not forget to use this r. Let me show this with more clarity, because here the concepts are quite important, and when you solve problem, we should understand why we should use this negative sign. Let me do one thing. From this relation to this relation, I am giving you the complete journey so that you can understand this. Assume that this is the earth. Once again, I'm taking this as a spherical, complete spherical body, right? Of radius r. And I choose a point somewhere here. I can choose the same point here also. Here also, right? I want to choose a point which is on the surface. This point is on the surface and is obviously at a distance capital R from the center of the earth. Let the mass of this point mass is small m. How much is the potential energy of this small m? According to the basic equation which I have there, it is minus g mass of the earth, mass of the body divided by r. Agreed? R square nahi likhna. It is r only, right? If I take this body to some height, small or large, let's not go in that detail. At this stage, the separation now becomes r plus small h. So how much is the potential energy here? Minus g m divided by let me call this as u1 and this as u2. Which is more, u1 or u2? Think again. u2 is more because of this negative sign. Agreed? And this, of course, you agree with me that if I lift a body up from the surface of earth, I'm increasing its potential energy. So what I do is, I do the difference of the two. du is equals to u2 minus u1. Quantity which is more minus the quantity which is less. So obviously, I must get delta u to be positive. More minus less, definitely this difference is always a positive. Minus g m r plus h minus of minus g m upon r. Agreed? This minus and minus will make it positive. I'm taking it with g m out, 1 by r minus 1 by r plus h. Okay? Let's remove this part. If I further simplify this, g m in the denominator I have r plus h, r plus h minus r and r is out. I get this as delta u as g m h divided by r plus h. Agreed? Let's take r out from this bracket. If I do this, this is g m h, 1 r with this r will make it r square, 1 plus h by r. Okay? Take this out. g m r square h divided by 1 plus h by r. Can you recognize this? This small g, acceleration due to gravity on the surface of earth. Let's put this as m first, G later, H here. 1 divided by 1 plus H by R. In fact, this is the exact expression for the potential energy. This is the exact expression for the potential energy difference rather between the position of two positions for a particle of mass m. One is on the surface of Earth, another is at the height h. But if you are sure of it, that h is very, very small as compared to the radius of Earth, you can easily ignore this h by r in comparison to 1. So in this particular condition, I can then write delta U very close to mgh. So I think this point is quite clear to you, that if you are using the formula mgh, that is for the potential energy difference, not for exact value of the potential energy. Number one. Number two, can only be used when h is very, very small as compared to r, and can only be used if you are talking about a point mass, as I told you. This is minus gmm by r is the general expression for the potential energy. If you are not sure of these assumptions are applicable there in your question, you do not use this mgh, you prefer to use this one. Let's understand this with an example. Let's understand this with an example more in detail. Suppose there is a question like this, that there is a body of mass small m and is dropped from a height equal to the radius of Earth, say from rest position. There's a body of mass small m released from a height which is equal to the radius of Earth. Remember, height is taken from the surface of Earth, not from the center. Ignoring the air resistance is not there. Body reaches on the surface of Earth, and we have to calculate the velocity with which it strikes the ground. Now I am very sure that I cannot use the formula mgh in your one-dimensional motion, that is the kinematics. You remember this formula, that if I drop a body from a height, the velocity is equals to under root of 2gh. I cannot use this formula now. Why can't I use this formula? Because height is rather equal. It is not very small. So don't use this formula. What we should do then? Calculate the potential energy at this position, take the difference and use the conservation of energy. What is the potential energy if I take the mass to be m here? Minus gmm by r. And what is the potential energy at this position? Minus gmm by 2r. Between r and r, that is 2r. Which is more, u1 or u2? u2 now. u2, because of this negative sign. So the negative sign is very crucial. So coming from this position to this position, the body is decreasing its potential energy. So if there is a decrease in the potential energy, where this energy is going? Is converting into the kinetic energy. This is what the conservation of energy is. So use this formula. u2 minus u1 is equals to half mv square minus 0, because kinetic energy is 0 in the beginning. So I write that minus gmm by 2r minus will make plus gmm by r is equals to half mv square. If you add, this becomes gmm by twice of r minus half plus 1 will make it 1 by 2 positive. It is once again half mv square. Small m will be out. This 2 and 2 will be out, and your velocity will become under root of gm by r only. I can do one thing. I can multiply it by r and I can divide this by r. That will help me to just sum up gm by r square. Nothing but the small g r. If I use this one, I will get the expression as 2gr under root. And definitely this option will be there in the 4 options. This you have to decide. So by now, I hope you must have understood this, that if h is comparable to the radius of Earth, then mgh is not a right formula for the potential energy difference. Is it clear? So the point where the examiner is deliberately is making question, and the answer which you may expect using a wrong formula mgh definitely will be there in the options, right? So you be clever enough to detect this and use the right formula for the potential energy. With this, we come to the next point. Potential energy is negative, right? But if I can make this energy zero by putting some positive energy, say for example a kinetic energy, I can make the body to escape. I can make the body to escape from the gravitational attraction. Mass m, g is the universal gravitational constant, radius is capital R, body is lying on the surface of Earth, right? If it is at rest, its potential energy is minus gmm by r. You put a negative sign because there is a force of attraction. What if I add the same amount of energy but with a positive sign? See, kinetic energy is always with a positive sign. Potential energy can be negative, but kinetic energy is always positive. I add to this some kinetic energy such that the total becomes zero, which is neither negative nor positive. So if I make this arrangement, that means I'm making the total energy zero, and that is possible only when the body reaches at infinity. And when it reaches at infinity, there is no gravitational force of attraction. We say that the body has escaped from the gravitational attraction. If you simplify, you'll get your answer as root 2gr. This is 2. It's not 3. It is 2. V escape is equals to under root of 2gm by r. You can simplify from here. Half mv square on this side minus gmm by r here. So you can take this 2. This becomes 2gm by r. But when I use this formula, I must keep this picture in my mind. The body was initially at rest. Okay, and I want this body to reach to infinity, but I don't want to give it any kinetic energy at that stage. So this is the minimum value of the velocity which I need to make a body to escape. But have you noticed that I'm using the energy concept in this? At this stage, I would make one point regarding the surface of Earth. See, when I make this diagram, most of the time I'm showing my particle here. It is not necessary. Not to scale. If I show a person standing here, I can show like this. But this also is the surface of Earth. If a person is standing here, will stand in this position comfortably. It is not to scale. One man is not having such a height, but this man is comfortable. So for him, this tangent direction is the surface. For this man, this tangent direction is the surface. This radial direction, radially outward, is a vertically upward direction. I'm standing here. So I say this is my vertically upward direction. This direction is nothing but is a radially outward direction. I may be anywhere on the surface of Earth. Same is the position here. This man is not falling. Why is it not falling? Because of the gravitational attraction towards the center of the Earth. And this man is also equally comfortable as this man if we assume the temperature is same, right? Because these are the pole positions according to the geometry. Anyway, so when I say the body is on the surface, it is not that always here. It may be here, it may be here, it may be here, but in a tangent direction, right? So tangent direction is taken as a horizontal direction, and radially outward direction is taken as a vertically upward direction. And radially inward direction is taken as a vertically downward direction. This is in three-dimensional picture. You please keep this in mind. Now with this, if I say, okay, from the surface of Earth in radially outward direction, the escape velocity minimum is under root of 2 gm by r. Can you tell me what will be the escape velocity if I make the body to incline at an angle of say 60 degree with the vertical? If I want to project a body at an angle 60 degree with the vertical, what will be the minimum velocity to make the body to escape? Cos 60. Cos 60 is half. Can I say I need half the velocity? Can I say this? No. Why not? Because the concept involved is the energy concept. Whether you make the body to go like this or like this, the kinetic energy which you are giving to the body is half mv's escape square, and the potential energy is minus gmm by r. Ignoring the air resistance, escape velocity is not dependent on the angle of projection, even if it is horizontal. Say, for example, for Earth, it is 11.2 kilometer per second. That is the escape velocity. If a body is moving horizontally with this velocity, the body will escape. It doesn't matter whether it's projected vertically up or is given horizontal direction, because it's the energy concept. So whenever you are using this escape velocity concept, since it's the energy concept, so take it from the energy aspect. So directional aspect is not there. That may be there when you're talking about a force. You can take a component of a vector, but you can't take a component of a scalar quantity. I'm not saying velocity is scalar, but the basic concept comes from the energy concept. Energy is a scalar quantity. So nothing to do with the angle in this case, right? These are minor things, but to be kept in mind. Next slide, sir. Here I'm giving you a lot of formulas, right? Potential. The way we have a unitary method for force in terms of the field, we have the similar aspect for potential energy, and we call this as the gravitational potential. If you look at carefully, this is also work done from infinity to r, but with a small difference. Look, instead of the force I have here g, and g is the acceleration due to gravity. Can I write this as force by mass? Can I say this is the work done per unit mass in bringing the body from infinity to that position? So if that is the case, the potential is defined in the same manner. Gravitational potential at a point in a gravitational field of a body is defined as work done in bringing a unit mass, or you can say per unit mass, and that is given as g dot dr. So it is not the force, it is rather force per unit mass if we talk about the potential. Let's collect, before we proceed to the next slide, let's collect some of the quantities which we have discussed so far. So many quantities we have discussed. First, force. Its vector, unit is a Newton. Agreed? The second quantity we took, gravitational field intensity. This was gravitational force per unit mass. So its unit was Newton per kg. Per unit mass. Third, gravitational flux. Since it was gravitational field into surface area, so this was Newton per kg meter square. Newton per kg because of this g, and surface element because we have in the unit meter square. Then we took a quantity, potential energy. Whatsoever be the formula, since is energy, so its unit is joule. And now we took one more physical quantity. We call this as the gravitational potential. I am writing it as V. See, symbols one can change, right? In some books you may find that for potential energy they are writing V. Don't get confused. Symbols is our choice. If you find, say, some symbol is quite, say, you are comfortable with, use it, but you must mention it, that this is a particular quantity which we are taking. Anyway, for competitive type of questions, it doesn't matter much, right? Because you have to solve it. Once you understand the quantity, symbol may be any. For potential, this is work done per unit mass once again. So this you can write as joule per kg. What this? These are the 5 physical quantities we have just discussed so far, right? Of course, you need some details of this gravitational potential for various systems. In the first lecture, I am not giving you very complicated cases. We are taking some of the simple cases for which you have to remember the formula, because we can use these formulas directly while solving the problem. Next slide, sir. For a point mass that you can remember easily, do you remember the formula for 2-point masses when we are talking about the potential energy was minus G M M M1 or M2 you may write, divide by R. But what is V? V is the potential energy per unit mass. The formula will be minus Gm by R. For force, it was minus G M1 M2 divided by R square. For gravitational field, this was minus Gm by R square. See, there are small differences. This is mass, one mass is missing from here. The mass which is responsible for the gravitational field intensity, that mass is there, but the mass which is kept at that point is not there. This is a gravitational flux. I told you this is equals to the flux for a closed surface according to the Gauss law is equals to minus G4 pi summation of the mass. This I am leaving because we'll see that in detail later, right? Maybe tomorrow we'll go more in detail with this concept and I'll convince you, yes, use of this flux concept will make your question extremely simple. You can answer the things in a faster manner if you can make use of this concept of flux. Potential formula for a point mass is this. One more thing which I would like to mention here so that you have quite clarity between them. Force and potential energy. These two properties are the properties of system of masses. System of masses. You need at least 2 objects to tell me what is the gravitational force. I cannot say if I have a body of 1 kg and ask you what is the gravitational force on 1 kg. then you should ask me, where is the other body? Is it the earth or some body in the surrounding? You need two bodies at least. For potential energy, do the same. For potential energy, again, the potential energy is between the two bodies. You can't have a potential energy of one body. But when I talk about the gravitational field intensity and the potential, I will ask you like this, that the potential at a particular point, I'll not talk about the system there, right? So this G and V are the properties of point. Force, potential energy are the properties of a system where you need at least two bodies, right? So these are the things which you basically require. Now we have some relations. Since we are discussing only points, I'm not going in the details of it. Can I have that pointer? Its battery is not there. Okay, no problem. I'll just show it here, right? That is the easy way. See, these are the few relations which I should ask you to remember with some of the detailing of it, but not, let's not go in the basic aspects of it, how we get it. This is a hollow sphere. It means that nothing is inside. It's completely hollow. Its radius is capital R, and I choose a point P. I choose a point P, and the distance of this point from the center is small r. If small r is less than capital R, if small r is less than capital R, I am inside this sphere. If this small r is more than capital R, I am outside the sphere. If you look at the pattern of this potential V with small r, it is constant till you reach at a position which is equals to R. And the value is, for inside point, minus Gm by R. But please care for the distance I am counting. It is R, capital R. Capital R is the radius of the sphere. Whether I am at the center or somewhere here or even on the inner surface, the potential is same. But if when I go outside this, when R is greater than capital R, outside, the value becomes minus Gm by small r. Small r is a variable quantity. Small r is a variable quantity. As you move out, the r keeps on increasing. Now denominator is increasing. If I am showing the potential with a negative sign on this axis, obviously this will keep on decreasing. In fact, this value is increasing because potential is negative, as we discussed. So this keeps on decreasing. This pattern you have to keep in mind, because this we are going to use, right, in certain questions which normally are asked in competitive examination. So this formula you require, right? Next one. If it is a solid sphere and is uniform, for outside point the potential is same. For outside point the potential is same. But for inside point the potential is different. For inside point there's a bit complicated formula, but you have to have it. There is no way out. Minus Gm free r square minus small r square divided by 2r cube. If I get the time, then I'll show it to you how we get it. But as a basic point, what one can do, you can choose a small hollow sphere, say of a radius x, thickness dx, write the formula for it and do the integration, right, to come to this, but keep that in mind, right? Remember it. And the pattern variation goes in this way. Look, this is decreasing first of all up to the position which is the radius, and then further decreases like this. And at this position, which corresponds to small r 0, when small r is 0, when this r square is 0, this becomes r square and r cube, they will be out. So this is minus 3 by 2 gm by r. This 3 by 2 gm by r, I am taking the negative axis on this side. One can do it. You can take the potential this way with a negative axis. You have to mention that, that's only thing. Or you can take it on the other side too. So you have to look at the, in some questions, they even are asking the pattern of variation for the potential. They give you a system and they ask you how the pattern is there in diagrammatic form. They may ask you how the potential is changing with the position. So this is one which you should remember, right? Anyway, we'll derive it if time is there. Next, sir. Gravitational self-energy. Let's do this problem at least. If I give you a body and I ask you to break it into the pieces, you have to do some work on it. If you are given a walnut and you are asked to take it into the pieces, to take out the nut from it, you have to hammer it, or you have to apply a force from your mouth if your teeth are so strong. But in all the cases, you are doing some work. Agreed. Why you are doing work in breaking it into the pieces? Because all these pieces are experiencing the gravitational force and they are making a body, and their potential energy is negative. If potential energy is negative, it means I have to give that much amount positive to separate all these two pieces. The energy minimum required to break it into the pieces and separate them out to such a distance that there is no gravitational force between them is called its self-energy. And this self-energy here is given for a spherical body. Please understand the calculus done here. This is very important. This is the body of mass capital M. And as I told you that in calculus what we do, we start with some simple system. Let's say that a sphere of radius small r is already made by collection of the particles. And on the top of it, I have to collect some particles so that its radius will change by an amount dr. What I'm saying? I already have a sphere of radius r, and I'm collecting from the various sides the masses to collect on the surface so that its radius now will become r plus dr. That means I'm getting an increment of the radius which is equals to dr. So this is the starting point of your calculus. You will be given a system where you have, say, a variation. You start with a simple system, write an expression for it, and then go ahead. But in fact, what I did, to this sphere, I brought a envelope which is in the form of a hollow sphere of thickness dr. See what I'm saying? I already have a sphere of radius r, and I collected a hollow sphere of thickness dr on the top of it. And for this, I have to change the potential energy. By how much amount I have to change? Look at my formula. Minus G, this is M1, this is M2. I'll just tell you how we get it. Divide by R. You agree with me? Potential energy expression was minus G M1 M2 by R. Agreed? What is the mass of this? This is a sphere. 4 by 3 pi r cube, that is the volume multiplied by density. Agreed? How do I get the mass of this shell of thickness dr? I'm giving you a simple picture. Let's not go in much mathematical complication. Let's talk about this shell only. Now this portion which is additionally been put there. If I ask you to rupture it and put it in a form of a sheet, right? This envelope in the form of a sheet, how much will be its surface area? Because its radius is almost r, surface area will be 4 pi r square. Say this portion, if it is taken in the form of a sheet, the area will be equals to 4 pi r square. And how much will be its thickness? dr. The thickness will be dr. So what will be its volume? 4 pi r square into dr. If multiplied by density will give me mass. This is what I did. 4 pi r square dr multiplied by the density. Right? I got an expression where I have only one variable. See, this is very important. When you are going for integration, before going for integration, you should check, is it that there is only one variable? If you have two, then you have to somehow manage to get one. Right? If you can establish a relation between the two. If you simplify, I get this factor r square r cube. 1r makes it r to the power 4. Rest are constants, pi square and so on. Now I should integrate because I have to develop the body to a radius which is equals to capital R. If you look at the process, I have this sphere of small r, I'm increasing its radius, further I'm increasing its radius and so on till I increase the radius to capital R. It means I have to integrate it from 0 to capital R. Rest is constant except this r to the power 4. When you integrate this, a power is increased and increased power is divided, right? So this gives me r to the power 5 divided by 5. That's why we have a 5 here. And if you further simplify, you get the value as minus 3 by 5 gm square by r. So it means this is the self energy of a solid sphere. You need the positive 3 by 5 gm square by r to make this body to break into the pieces which are so separated that there is no gravitational force between them. Is it clear? So this is how you can make use of the calculus in solving these type of the problems, right? This is self energy. Is it clear? Right? Next. Very interesting and very important also, a topic from gravitation. This is the technological application of gravitation. Satellite, maybe natural, maybe artificial. If I can make a body to revolve around, say, a planet of mass m and radius r in such a way that the centrifugal force is balanced by the gravitational force. Centrifugal force balanced by the gravitational force, I can keep this body revolving, maintaining its distance from the center of the planet. See what I'm saying? This is a planet of mass m and the satellite here, which is expected to move in a circular orbit. I'm taking a circular orbit for ease. How can I maintain this satellite revolving around? Gravitational force is providing the necessary centripetal force. Because of this circular motion, there is another force which comes, and that is nothing but is a centrifugal force. Centrifugal force or pseudo force can be written as, if this radius is r and this height from here to here is h. So this centrifugal force will be mv square by r plus h. And how much will be the gravitational force? G M M R plus H whole square is equals to mv square by R plus H. Why I'm not using a negative sign here? See, my first expression was minus G M M M1 M2 by R square. Why I'm not using a negative sign? So this negative sign is very crucial. I told you, whether we are using it or not using it, you must understand this. Otherwise, it brings one thing. If I use a negative sign here, do you think a negative quantity can ever be equal to a positive quantity? No. That negative sign is because this force is acting in this direction. That is the force of attraction. I could have written this equation, same equation, like this: minus GMM by R plus H whole square. In addition to this, I have a force mv square by R plus H, and in total must be 0. That's why the system is in equilibrium. If I do it more accurately, if I choose this axis as my x-axis, in a more appropriate manner, I should use I cap, because force is a vector quantity. But if it is on a line, and one is, say, radially outward, other is radially inward, even if I'm not using I cap, it doesn't matter. So you have to keep your equations as simple as possible. But during this process, we must not miss some information. So even if I'm putting like this, I can say like this: I'm equating the two magnitudes, not two force as a vector quantities, right? Either this or this is one and same thing. So if you solve it, this m is out from the scene, and we are getting a velocity which we call as the orbital velocity. 1r plus h is also out. That is equals to gm divided by r plus h under root. So this is the orbital velocity which is necessarily required for a satellite to remain in the circular orbit, right? This is called the orbital velocity. Slides, previous slide. Yeah. So the formula for the orbital velocity is gm r plus h. But when you remember this formula, do remember that this is for the circular orbits only, right? How much time it will take to move around? To get this time, we are using a one simple concept. The total path is 2 pi r plus h. That's the total path in one round. And if you divide by the orbital velocity, we get nothing but the time of revolution. If you solve, you will get the factor t equals to 2 pi r plus h whole cube divided by gm there. This is very interesting thing. What happens if t is 24 hours? If the satellite is revolving around Earth in 24 hours, Earth also revolves around its own axis in 24 hours. So what we'll notice, if somebody is there on the Earth, he'll find the satellite appears to be stationary. It is not stationary. It appears to be stationary. That's why we call such a satellite as a geostationary. Geo actually is a word used for Earth. So from Earth, it appears to be stationary, though it is revolving around, right? So, and the height is nearly, it is not exact value, it is 36,000 kilometers. If I want to make a satellite to become a geostationary satellite, I have to increase its height. Please remember, it is not the radius. For radius, you have to add 6,400 kilometers additional to this. So that satellite will appear to be stationary from Earth. All your communication satellites are geostationary satellites. Those satellites which are remote sensing satellites, they are at the lesser height, say nearly 600 kilometers to 800 kilometers. But then, since the radius is less, height is less, so they complete their revolution in lesser time. So they make many rounds in a day. and geostationary satellite remains at the same place, right? Appear to remain at the same place. It's one or two more slides for the theory part. Potential energy, now you can easily write. Potential energy of the satellite minus gm1m2 divided by the distance from center. Center distance is r plus h is mine, and minus sign is to be kept. Minus sign is to be kept. Kinetic energy, half mv square. V is the orbital velocity. You have the formula for velocity. You can use it here to get it. And what is the total mechanical energy? You don't take it as a total energy. It's total mechanical energy, which is sum of the two. That means the potential energy and kinetic energy. This is negative. This is positive, but a factor of half is there. So finally, we get this negative sign with a half factor gmm by r plus h. In your IIT competition, they are asking many times a relation between the total energy and say the kinetic energy. Can I write this looking at the expression that the total energy of the satellite is minus kinetic energy of the satellite? Look at this. Obviously, because the negative sign here. And what will be the relation if I write the potential energy? Potential energy, see the kinetic energy is negative, so is minus twice the kinetic energy. They may not be asking you the relation, these relations directly. They may be asking in this tricky way. They give you options, how the potential energy is related to the kinetic energy like this. Or maybe the kinetic energy and potential energy also can be related this way. So these are the, say, format in which the same similar equations are asked, right? But I told you this is a simple way to remember it. Potential energy expression you keep in mind. Kinetic energy is half of it, but positive. So total if you add becomes minus of half. And what this negative sign is doing here for the total energy? Due to this negative sign, we say that satellite is in the bound state. It remains bound to the Earth. If I want to make this to escape from here, what do I have to do? I have to make the total energy to be 0, right? From this relation, let me ask few things to have the understanding of it. Suppose is Earth, this is a satellite S1, satellite S2. This exercise will actually teach you all these things in detail. This height is H1, and say this height from here to here is H2, and obviously H2 is greater than that of H1. Let's do a very simple exercise. If I ask you, V1 is the orbital velocity of the satellite S1, and V2 is the velocity, orbital velocity of satellite S2. Which of the two is more? Look at your options. You have the formula with you. Which is more? V1 is more than that of V2. Check where the R plus H comes. Velocity orbital is under root of gm by R plus H. It is not negative. It is not negative. It is positive. So if H is increased, orbital velocity will decrease. So the satellites which are far away from Earth, they are moving slowly. And those satellites which are close to the Earth, they are moving fast. That's why I told you, the satellites which are remote sensing satellites, which are at a height of 800 kilometers, they are taking many rounds of Earth in a day. Geostationary satellite, which is at a height of 36,000 kilometers, is making only one round in a day. Now, if I ask you time period of 1 and time period of 2, obviously, this is greater than that of T1. Why so? Because for time you have a formula 2 pi under root of r plus h whole cube divided by gm. So h comes in the numerator here. This in fact is nothing but is a Kepler's law. Is a Kepler's third law. In fact, we'll talk about this later on. And if I ask you which of the two has more gravitational potential energy, think of it. No need to hurry up the things. Yes, this is S2. Potential energy, as you go up, potential energy keeps on increasing, although H is in the denominator. But the potential energy is minus Gmm by R plus H. Because of this negative sign, the situation is like this. And if I say the masses are same, let me put this condition. This condition should also be there even for the potential energy. We should have same mass, otherwise you can't compare. What about the kinetic energy? If I call this as EK1 and EK2, which of the two is more? EK1 is more if masses are same, because that is going faster. Good. And what about the total energy? E1 and E2. But for the total energy, as you have written, is equals to minus half G M1 M2, that is mass of the earth and the body satellite, divided by R plus H. So one which is having a greater height, this is very less, but negative sign makes it more. So energy of this E2 is more than that of E1. So you should have a very clear picture that where you are using a plus sign, where you are using a negative sign, because that plays a great role in decision making type of the question, where you have to decide which is more and which is less. If I, this is a question, let me just take the question. Will there be any change in the acceleration due to gravity if the earth stops rotating? Yes, except at one position. Let me explain this question. It's a good question. We have effective acceleration due to gravity, G minus R omega square cos square lambda. This is a formula which you should use. If earth stops rotating, omega becomes 0. Omega goes 0. That means the factor which is with the negative sign, if that is removed, the value of the G will increase. But this is a very interesting thing. At pole, the value is already G. At poles, where the latitude lambda is 90 degree, the value is already G. It is not going to affect the value. So you may say like this, if earth stops rotating, the value of the G will increase everywhere except at poles. That's the answer. Negative sign is basically, this is of course, I discussed this at length, and that is quite crucial, at least for such type of the questions where they're doing the comparison. The negative sign for potential energy is because the gravitational force is a force of attraction. In a nutshell, I'm saying this, if there is a force of attraction, the potential energy is negative. In general, don't take any reference. Reference case is different. And if there is a force of repulsion, the potential energy is taken as positive. For that, I'm giving you one reason. For 1D cases, for one-dimensional cases, that means where we are moving one-dimensionally, force is given by minus du by dr. It's very important relation. U is the potential energy and R is the distance. Force is related to the potential energy like this. Let me draw a potential energy curve. In general, suppose I have this type of a curve. If I'm somewhere here, look at this. With the increase in R, the potential energy is decreasing, say for this part. It means if I'm increasing R, if it means dr is positive, potential energy is decreasing, that means it's negative. Negative and negative will make this force positive. So I say that in this portion there is a force of repulsion. And if I am here at this stage, as R is increasing, potential energy is increasing. So both are positive and this is negative. Force comes out to be negative, that means the force of attraction. And at this particular position at the top, there is no change, or you can say the slope du by dr is 0. There is no force, and we call this point as the point of equilibrium. Even this is the point of equilibrium. So in a nutshell, the negative sign in potential energy is due to the attractive nature of the gravitational force. Third one, the same question, right? This is the same one. What is the negative sign denotes in the potential energy? Third question is similar to the second one. Any more doubt there? Okay, so just can you show me the last slide? Last one, slide where we reached. We're talking about the energy. So we'll discuss the Kepler's law tomorrow morning, right? So let me quickly give you in nutshell the very, very important points which you should not forget for the gravitational concept. I told you the gravitational force is the weakest force. Weakest force of all the forces known to human being. But it's a long range force. It has a range extending to infinity. It is the central force. Due to the central force, whenever we are using the motion under gravitational force, I can use the law of conservation of angular momentum, provided that the axis is properly taken care of, right? Second thing, this gravitational force can be expressed in terms of the gravitational field intensity by unitary method. That means the force experienced by the unit mass. Once I know this, I can calculate the force. Say if I replace that point by any mass, once I know the gravitational field intensity. Third point, I told you that there is a concept of the field lines. If I have a mass, then any such line where the tangent drawn is giving me the direction of the gravitational field intensity, I call that line as the field line. This may be a curved line also. It is not that it's always straight. Curved line. If it is a curved line like this, then at this point the tangent drawn is giving me the direction of the gravitational field at this particular point. Then I told you as a fourth point, potential energy. Gravitational potential energy concept is one of the most important concept. But the negative sign which I told you is very crucial. You should not forget this. And general formula for gravitational potential energy is minus G m1 m2 divided by R for 2-point particles. This negative sign you should not remove in any case. mgh also is a potential energy, but exactly it is potential energy difference taken with respect to some reference. There you can have potential energy positive, there is no problem, but otherwise in general the potential is never positive. Then gravitational potential. Potential also is like a unitary method, is a gravitational potential energy of a unit mass placed at that particular point, right? So flux, I told you, flux I'll discuss even more in detail while taking a problem. Flux I'm deliberately skipping because of we'll want more discussion on that particular aspect. I hope these 4 quantities are clear to all of you. Now any doubt from this portion? Understood everything? Sure? Yes, okay. Thank you.